A while ago, I was thinking, what if I made a math super video? A video that has all of my elementary math lessons in one place. The ultimate elementary math video. And I thought, yeah, that would be cool. I've got to do that. And here we are. Now, this video has chapters. You could skip to the parts you want to learn, or you can go with the flow. I mean, this is your math adventure, okay? Welcome to the fun. It's time to begin. Let's go ahead and start with addition. Just look at this plus sign. It looks so happy. I love the gloves, the shoes. It's a fancy plus sign. It definitely looks like it's ready for addition. Addition is awesome because we can see what happens when numbers team up, when they combine. We're going to be putting numbers together. That's what addition is. Let's say you have 3 strawberries. Very cool, very tasty, and someone offers you another strawberry. So you add that strawberry to your collection. 3 strawberries plus 1. This plus sign tells us we're doing addition. What's 3 plus 1? Yeah, 4. The number 3 plus 1 is 4. We're just putting numbers together. Okay, I have 1 carrot and I get another carrot. 1 plus 1. How many carrots do I have now? Yeah, 2. 1 plus 1 is 2. I have 2 carrots now. All right, let's say I have 5 carrots and someone offers me more, but I politely say, no thank you, I have enough. So I had 5 and we're adding no more carrots. 0 carrots. 5 plus 0. What is 5 plus 0? Yeah, 5. If you add 0 to a number, the number doesn't change. You're adding nothing. Great job. Now, the only issue with these carrots is I couldn't eat them. I don't eat carrots that look at me, you know? I just don't. Hey, I've got an idea. Let's go shopping, okay? We can add up the things in our cart. Okay, this is awesome. We're going shopping, and we're in one of my favorite sections of the grocery store, the produce section. I put 3 bananas in the cart. There are 3 things in the cart. The 3 bananas. I love bananas. And I put 3 lemons in the cart, too. Hey, everything in the shopping cart is yellow. That's pretty cool. Let's add these numbers together to see how many things are in our shopping cart so far. What's 3 plus 3? 3 plus 3. Yeah, 6. Awesome job. We can double check that by counting them. 1, 2, 3, 4, 5, 6. 3 plus 3 equals 6. I have 6 things in my shopping cart. But we're not done shopping. I would like some apples. Wow, they look super delicious. Let's go ahead and buy 4 of them, okay? To find out how many things are in the shopping cart now, we just need to add these 4 apples to the 6 things that are already in there. What is 6 plus 4? 6 plus 4. Yeah, 10. Great job. 6 plus 4 equals 10. Awesome job. We can count that out together to double check. We'll start at the number 6, since there were 6 things in the cart to begin with. 6, 7, 8, 9, 10. 6 plus 4 equals 10. Okay, let's switch gears a little bit here and visit a dog park. A dog park. Let's say there are just 5 dogs at the dog park and 2 more dogs arrive. To find out how many dogs are in the dog park now, we just add 5 plus 2. What is 5 plus 2? 5 plus 2. 7. There are now 7 dogs in the dog park because 5 plus 2 equals 7. Wonderful job. So there had been 5 dogs, and with the 2 dogs added, 6, 7. 5 plus 2 equals 7. What if there were 4 dogs in a dog park, and later 4 more dogs showed up? How fun! What is 4 plus 4? 4 plus 4. Yeah, 4 plus 4 equals 8. Great job! 4 plus 4 equals 8. We had 4 dogs at the park already. Then we just added 4 more. 4, 5, 6, 7, 8. 4 plus 4 equals 8. You've done great. Now I want to see how many of these you know. What's 3 plus 0? 3 plus 0. Yeah, 3. If you add 0, you add nothing. The number stays the same. Awesome job. How about this one? What is 7 plus 1? What is 7 plus 1? You got it! 8! 8 is 1 higher than 7. If you have 7 and add 1, you get 8. Fantastic! Let's try 2 plus 4. What is 2 plus 4? 2 plus 4. 6. 2 plus 4 equals 6. If you have 2 and add 4 more, you get 6. Wonderful! Next, let's do 4 plus 5. What's 4 plus 5? 4 plus 5. Yeah, 9. Great! 4 plus 5 equals 9. If you have 4 and you add 5 more, you get 9. 4 plus 5 equals 9. Amazing job. All right, let's try this one. What is 3 plus 4? What is 3 plus 4? 7. Fantastic! If you have 3 and you add 4 more, you have 7 in all. 3 plus 4 equals 7. Well done! Here's our last one. What is 8 plus 2? 8 plus 2. Wow, 10! Yes! 8 plus 2 equals 10. If you have 8 and add 2 more, you get 10. 8 is just 2 away from 10. So 8 plus 2 equals 10. Wow, this hamster is still sleeping. I guess it's like the lullaby music and, the hamster's just comfortable. Just getting a nap. Just taking a nap. Addition is awesome because we can see what happens when numbers team up, when they combine. You did a great job. Addition is fun and it's pretty easy, isn't it? When you add, you're putting numbers together. All right, we're looking at 2 ducks. Okay. Oh, wait, is another duck going to join them? How does this show addition? I'm confused here. Oh, there's a 3rd duck. 2 plus 1 equals 3. There are 3 ducks. It does show addition. Addition is all around us, which is great because it's awesome. It's just putting numbers together. Great job learning about addition. Okay, you can dance or stretch for a moment. Yeah, very cool. Learning about addition was really awesome. And you know what? There's so much more fun ahead, okay? Because next, we're going to learn all about subtraction. Subtraction. That's kind of a big word, but don't worry, it's actually pretty easy, okay? We're going to take a fun look at how subtraction works. And soon you'll be subtracting like a pro. Kind of like this owl, all right? Show us the ways of subtraction, owl. You can just tell this owl knows a thing or two about subtraction. But you know what? It's time to jump right in. Now, subtracting is just taking numbers away. How many dogs do you see? Yeah, 3. But 1 dog leaves. He has something else going on right now. How many are left? Yeah, 2. There were 3 dogs and 1 left. 3 minus 1. This minus sign is what we use when we subtract. How many were left? Yeah, 2 dogs were left. 3 minus 1 equals 2. That's subtraction. Or let's say you have 2 carrots, which is great. Carrots are absolutely amazing. and you give 1 carrot to a bunny, for her birthday. We'll need to subtract 1 carrot from the 2. What is 2 minus 1? Yeah, 1. You would have 1 carrot left. 2 minus 1 equals 1. Oh, we're in a bakery. How cool is that? There are so many baked goodies here, and plenty of customers are here to buy them. Let's say the bakery had 5 of these pies, and they sold 2 of them. To find out how many are left, we have to figure out what is 5 minus 2. What's 5 minus 2? Yeah, 3. Great job! So there were 5, and then 2 of them were sold. After we subtract 2, 3 are left. 5 minus 2 equals 3. Now, what if the bakery had 8 plain bagels, okay? And they sold 4 of them. To find out how many plain bagels are left, we have to figure out what 8 minus 4 is. What is 8 minus 4? 4. Great job. 8 minus 4 equals 4. There were 8 plain bagels, and then we subtracted 4. That left just 4 bagels. 8 minus 4 equals 4. Oh, it looks like some of the customers bought cupcakes! Let's say the bakery had 9 cupcakes, and their cupcakes have been popular. They've sold 7 of them. 9 minus 7 will tell us how many cupcakes are left. What is 9 minus 7? Yep, 2. 9 minus 7 equals 2. Fantastic job. If there were 9 and then 7 were sold, that would leave only 2 more cupcakes. 9 minus 7 equals 2. You are doing a tremendous job. You know what? I think it's time to test your skills with a fun subtraction game. Let's see how many of these subtraction problems you can figure out. Let's start out with this one. What is 4 minus 2? What is 4 minus 2? 2. Yeah. If you have 4 and then you take 2 of them away, there are 2 left. 4 minus 2 equals 2. Awesome. How about this one? 8 minus 1. What is 8 minus 1? Yes, 7. If you have 8 and you take away just 1, you have 7 left. 8 minus 1 equals 7. Very cool. Let's do this one next. What is 6 minus 6? What is 6 minus 6? Yeah, 0. If you have 6 and then take all 6 of them away, there are none left. 6 minus 6 equals 0. Great job. How about 4 minus 0? What is 4 minus 0? 4. Why is that? Yeah, because you are taking nothing away. You're subtracting 0. You started with 4 and took 0 away. So you still have 4. 4 minus 0 equals 4. Fantastic. Okay, what's 7 minus 6? I don't know if this owl knows, but maybe you do. What's 7 minus 6? Yeah, 1. Great. If you have 7 and you take 6 away, only 1 remains. 7 minus 6 equals 1. You are doing an amazing job. Wait, we've got penguins here. Finally, this video needed penguins. You know, the subtraction question is, what is 10 minus 3? What's 10 minus 3? Let's tell the penguins the answer. What is it? Yes, 7. 10 minus 3 equals 7. Nice one. And hey, thanks for being in this video, penguins. Have fun wherever you all are going. Maybe they're going to the bakery, the one we were just looking at. I mean, that would be cool, but come on. Penguins don't go to bakeries. Except maybe this penguin. All right, I've got a good one here. Let's try 9 minus 5. What is 9 minus 5? Good one. 4. 9 minus 5 equals 4. Wow, you are doing great. Wait, I never caught the camel's name. Billy? Charlie? Bob? Is your name Bob? Okay, let's try some more. This is fun. Do you know what 6 minus 3 is? What is 6 minus 3? Yes, 6 minus 3 equals 3. If you have 6 and take 3 away, you only have 3 left. Well done. Wait, there are only 3 cupcakes left? And now somebody else is taking one. Now there are only 2 left. This is subtraction in action. Hey, let's try another one. What is 8 minus 6? What is 8 minus 6? 2. 8 minus 6 equals 2. If you have 8 and subtract 6, just 2 are left. Great job. How about 7 minus 2? What do you think 7 minus 2 is? Yeah, 5. 7 minus 2 equals 5. Awesome! If you have 7 and take 2 away, there would be 5 left. Sweet! All right, here's the last one I'm going to ask you. What is 10 minus 4? What is 10 minus 4? Yes, 6. 10 minus 4 equals 6. If you have 10 and then subtract 4, there are 6 left. Way to go. Congratulations, you did great. Subtraction is really cool, and it's pretty easy, isn't it? Subtraction is just taking numbers away. How did we do, Owl? I just realized you don't talk or move, but you're good at subtraction. I bet that's your superpower. I bet it's your superpower. Very cool. Subtraction is a blast. Now we're going to take things to the next level, okay? We learned basic addition and subtraction, but sometimes we need to add or subtract bigger numbers, double-digit numbers. Whoa! Next, we're going to learn double-digit addition. Double-digit addition. Let's say there's this kid named Travis. Hi, Travis. Travis collects these. What are these called? Marbles. Travis collects marbles. Travis had a lot of marbles. He had 54 marbles. But today's his birthday, and someone just gave him 21 more marbles. Wow! And now he wants to know, how many marbles do I have? I had 54, and now I have 21 more that are in my collection. How many marbles do I have? That's the question that Travis has. What's 54 plus 21? Now here's the deal, Travis. You could count each of the marbles one by one to figure out exactly how many you have now. But that would take a long time. Look at all of these marbles. There has to be a better way. In fact, there is. There's a way that is super fast and super fun. We can add 54 and 21 together by doing a fun trick. We'll turn these big numbers that are difficult to add on their own into smaller numbers. What you will do is you will add the numbers to the right here, which are the ones. To make it easier, we are going to block the 10 spot for right now with this nifty blue rectangle. Suddenly, this huge big addition problem has turned into a simple, fun addition game. So we add the right spot, the ones spot together. What is 4 plus 1? Yes, 4 plus 1 equals 5. So we'll write 5 under the 4 and the 1. Awesome job. We're halfway done already. Next, we will add the 10s together. The 10 spot is to the left. The two numbers in the 10 spot are the 5 and 2. To make it easier, we are going to block the 1 spot with another blue rectangle because we already added the 1 spot up. What is 5 plus 2? 5 plus 2 equals 7, so we will write 7 under the 5 and the 2. So what is our answer? What is 54 plus 21? You can see it right here. 75. 54 plus 21 equals 75. The answer to an addition problem is called the sum. Our sum is 75. It's simple. With double-digit addition, you add the right side, the ones, together first. Let's figure out what 30 plus 12 is. First, what is 0 plus 2? Yes, 0 plus 2 is 2, so we'll write a 2 under the right side, the ones side. We've almost arrived at our answer already. Then we add the left side, the tens, to get our answer. What is 1 plus 3? Yep, 1 plus 3 equals 4. So the sum of this addition problem is 42. 30 plus 12 equals 42. Let's try a different type of addition problem. 33 plus 6. This is an interesting one because 33 is a double-digit number, but the number 6 is a single-digit number. But we use the same fun trick as before. First, we add up the ones. What is 3 plus 6? 3 plus 6 equals 9, so we write 9 here under the ones. Next, let's add up the tens, but there is only one number in the 10 spot, so what do you get if you add nothing to 3? You get 3. So what is our sum? Yes, our sum is 39. How are we doing? Double-digit addition is pretty cool, isn't it? Now we are going to talk about something special, really special. Special like seeing an owlet, a little baby owl looking at you, looking at your eyes, you know. Oh, so cute, so cute, so special. So what is this special thing we are about to learn? Well, sometimes something sneaky happens. Let's show you. Let's say we are adding 17 plus 15. We of course start with the right side, adding up the ones first. So what is 7 plus 5? Do you know? 7 plus 5. Yeah, 7 plus 5 equals 12. That's right. But there's only enough room for one digit under the 7 and the 5. So what do? Well, we do a super cool move called regrouping. Regrouping is awesome. Remember, the sum of our ones column is 12. 7 plus 5 equals 12. So we have to regroup the number 12. But what does that mean? What does regrouping even do? Well, regrouping splits the digits and puts them in different places. Now that might sound weird, but we're going to show you how it works. It's super simple and fun. Regrouping the number 12 is easy. All we do is split the digits, putting the 2 under the ones and carrying the 1 with the tens up here. That's it. Then we add up the tens. What is 1 plus 1 plus 1? Yeah, 1 plus 1 plus 1 equals 3. So we write 3 under the tens. And now we have our answer. 17 plus 15 equals 32. 32 is our sum. Remember, regrouping is only used when there is a double-digit number, but there is only space for one digit, like our example, 7 plus 5 equals 12. But there wasn't enough room for both numbers, so we keep the 2 under the ones and carry the 1 to the tens. Hey, let's practice by playing a game. The game is called Do We Need to Regroup? This is probably the most exciting double-digit addition game ever. Hosted by our very own Mr. Whiskers. Thanks for helping us out. You're not gonna help us out. Okay. Okay, now this is embarrassing. Okay. Fine. Okay. Alright. That's okay. That's alright. It's alright. Okay. It's okay. Alright, well, we are going to look at double-digit addition problems, and you are going to let us know. Do we need to regroup? Here is our first problem, 32 plus 19. You already know the question. When we add 32 and 19, do we need to regroup? Yes, because 2 plus 9 equals 11, which is a double-digit number. Remember, the first step we take is adding up the ones. But if the sum is a double-digit number, that means we need to regroup. Great job. Let's go ahead and finish the problem. When we regroup, we split the digits. So the first one gets carried, and the second number, in this case, also the number 1, stays down under the ones. Then we just add up the tens. What is 1 plus 3 plus 1? 5. So, 32 plus 19 equals 51. And yes, we did have to regroup. Here is our second one, 56 plus 22. This is the question. When we add 56 and 22, do we need to regroup? No, because 6 plus 2 equals 8, and 8 is a single-digit number that can fit under the ones. Remember, the first step we take is adding up the ones, and since the sum is a single-digit number already, we do not need to regroup. Fantastic. Let's go ahead and finish the problem. So when we added up the ones, our sum was 8. We'll put the 8 under the ones. Then we just add up the tens. What is 5 plus 2? 7. And we have our answer. 56 plus 22 equals 78. And no, we did not have to regroup. Here is our next one, 34 plus 25. This is the question. When we add 34 and 25, do we need to regroup? The answer is no, because 4 plus 5 equals 9, and 9 is a single-digit number that can fit under the ones. Remember, the first step we take is adding up the ones, and since the sum is a single-digit number already, we do not need to regroup. Well done. Let's go ahead and finish the problem just for fun. So when we added up the ones, our sum was 9. We'll put the 9 under the ones. Then we just add up the tens. What is 3 plus 2? 5. And we have our answer. 34 plus 25 equals 59. And no, we did not have to regroup. This is our last one. You have been doing great. 43 plus 37. You already know the question. When we add 43 and 37, do we need to regroup? Yes, because 3 plus 7 equals 10, which is a double-digit number. Remember, the first step we take is adding up the ones, but if the sum is a double-digit number, that means we need to regroup. Wonderful. Let's go ahead and finish the problem. When we regroup, we split the digits. So the number 1 gets carried, and the second number, in this case, the number 0, stays down under the ones. Then we just add up the tens. What is 1 plus 4 plus 3? 8. So 43 plus 37 equals 80. And yes, we did have to regroup. Wow, great job learning double-digit addition. Incredible! Remember how we looked at basic subtraction earlier in this video? Well, we're about to take subtraction to the next level by learning how to subtract bigger numbers. It's time to learn double-digit subtraction. Yes, double-digit subtraction. This is going to be fun. Let's say we have a lot of blueberries. For some reason, they're just hanging out on a wooden table. We need to wash them and put them in a bowl. Let's pretend that when we were putting them in the bowl, we counted them and found that we had 66 blueberries. That's a lot of blueberries. You and your friends are hungry and blueberries are super yummy, right? So you and your friends eat 54 blueberries. That's right. These are some big numbers, some double-digit numbers. To find out how many blueberries we have left, we simply subtract 54 from 66. Let's look at how that's done. Here is our subtraction problem again. 66 minus 54. With double-digit subtraction, all we do is break this big problem up into two little problems. First, we will subtract the right column, the ones. To make it a little easier, we are going to cover the tens column with this blue rectangle. Suddenly, this big subtraction problem is a really easy one. What is 6 minus 4? Do you know? Yes, 6 minus 4 equals 2. So we put the number 2 under the ones column, the right side. Great job. We are halfway to our answer. Next, we will subtract the left column, the tens. And this time we're going to cover up the ones column to make it a little easier. So, what is 6 minus 5? 6 minus 5. 6 minus 5 equals 1. We will write 1 under the tens, the left column. And just like that, we have our answer. The difference is 12. There are now just 12 blueberries. All right, let's do another one. How about 87 minus 53? This should be fun. First, subtract the right side, the ones. What is 7 minus 3? Yes, 4. So we will write 4 under the ones. Simple. Next, we just subtract the left side, the tens. What is 8 minus 5? Yes, 3. So we write 3 under the tens column. And we have our answer. The difference is 34. Double-digit subtraction is simple. First, subtract the right, the ones. Next, subtract the left, the tens. Then you have your answer, which is also called the difference. Now, there is something interesting that can happen when you subtract larger numbers. Here, we'll show you. Say we have this subtraction problem, 22 minus 17. Let's follow the process. So first we subtract the ones. What is 2 minus 7? Well, here's that interesting thing we mentioned to you. Say I have 2 carrots, and I need to give 7 carrots away. That's a problem. It's hard to give away more than you have. So what do? Well, we do a special trick. No, not this kind of trick. Wow, he is really high up there. No, not this kind of trick either, alright? It's a math trick, okay? It's a math trick. This is a subtraction video after all. The trick is called regrouping. Can you say that? Regrouping. Yeah, regrouping. When you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. Just like in this example, because it is hard to take away more than you have, and 7 is bigger than 2, so we need to regroup. So how does this regrouping trick work? It's really easy. All you do is borrow 1 from the tens column. What is 2 minus 1? Yeah, 1. So this number in the tens column becomes a 1. And that 1 that we borrowed from the tens, it goes to the ones. It gets placed on this 2 in the ones column. And now the ones column is 12 minus 7. Now we just have to follow our subtraction game plan. We subtract the right column, the ones first. What is 12 minus 7? Yes, 12 minus 7 equals 5. So we write the number 5 under the ones column. Then, of course, we have to subtract the tens, but regrouping made this super easy. What is 1 minus 1? Yes, 1 minus 1 equals 0. So our answer is simply 5. 5 is our difference. Remember, when you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. And with subtraction, regrouping means borrowing. In double-digit subtraction, regrouping is when you borrow 1 from the tens column. Let's try one more double-digit subtraction problem and see if we need to use the special regrouping trick. 43 minus 25. This is going to be awesome. Remember, the first thing we do is subtract the right column, the ones. But, 5, the bottom digit, is bigger than 3, the top digit. Time to regroup. So we borrow 1 from the tens column. What is 4 minus 1? Yes, 3. Then we put that 1 in front of the 3 in the ones column, making it the number 13. Then we just follow the process, subtracting the ones column first. What is 13 minus 5? What is 13 minus 5? Yep. It is 8. So we will write 8 under the ones column. Now it's time to subtract the tens. What is 3 minus 2? What is 3 minus 2? You got it. 3 minus 2 equals 1. So we put the number 1 under the tens column, and we have our answer. 43 minus 25 equals 18. 18 is the difference. We've learned a lot, but we need to make sure we are able to remember everything. Here's an idea. There's this guy, Mummy, who doesn't know how to do double-digit subtraction, okay? So we are going to do a double-digit subtraction review by teaching Mummy. It's simple and it's fun, Mummy. You'll love it. So, Mummy, subtraction is when you take numbers away. Sometimes subtraction problems can have little numbers, or other times subtraction problems can have bigger numbers, double-digit numbers. Here's how it works, Mommy. First, subtract the right column, the ones. Next, you subtract the left column, the tens. Then you have your answer, which is called the difference. Sometimes the bottom digit is bigger than the top digit in the ones column. This is something to get excited about, Mommy. It means you can use a special trick called regrouping. You just borrow 1 from the tens column and move it to the ones column. Then just follow the plan. Great job with double-digit subtraction. Oh my goodness, you did an amazing job. Whoa, a beaver. Could we get back to math? You know, it's a math video. I get that this beaver is itchy. I'm sorry about that, beaver, but we have to keep going, all right? We've got so much math to cover. Okay, now we're going to continue this incredible math adventure by looking at multiplication. That's right, multiplication. No wonder this owl is excited. Multiplication is awesome, and it's pretty easy once you get the hang of it. So let's roll right into this, starting with a question. What is multiplication? Well, multiplication is when you have a number a certain number of times. For example, a standard bike has 2 wheels, but if there are 2 bikes, then you have the number 2 times. In other words, 2 times 2. That's multiplication. This x tells us we're multiplying. The number 2 times is the same as 2 plus 2. It's the number 2 twice. How many wheels are there in all? What's 2 times 2? Yeah, 4. 2 times 2 equals 4. There are 4 wheels in all. You know, a motorcycle has 2 wheels also. Whoa, here are 3 motorcycles. To find the total number of wheels, we have the number 2 3 times. 2 times 3. 2 times 3 is the same as 2 plus 2 plus 2. It's the number 2 3 times. What is 2 times 3? Yeah, 6. There are 6 wheels in all. 2 times 3 equals 6. There are a total of 6 wheels when you have 3 motorcycles. Great job. Cookies. Yeah, let's practice multiplication with cookies next. Let's say a store sells boxes of cookies. There are 3 cookies in each box, and someone buys 3 of these boxes of cookies to enjoy with some friends. Now, to figure out how many cookies there are in all, you would multiply the 3 cookies times 3, because there are 3 boxes. 3 times 3. This is the same as 3 plus 3 plus 3. It's the number 3 times. What is 3 times 3? 9. Awesome! 3 times 3 equals 9. That means there are 9 cookies in all. 3 cookies, 3 times, means there are 9 cookies. We could even count the cookies to double check. 3 cookies, 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 equals 9. I don't know if I've mentioned this in any of my videos, but I love basketball. It's my favorite sport. I was obsessed with basketball as a kid and collected basketball cards. Actually, I still have my basketball cards. I keep them in my office and still look at them from time to time. They're really cool. Now, why am I sharing this? Well, when you collect cards, you're used to using multiplication. Let's say a new series of basketball cards has 6 cards in every pack. Every pack has 6 cards. And I have enough money to buy 3 of these packs. To find out how many cards I'm getting in all, we have to multiply 6 times 3. It's the number 6 3 times. This is the same as 6 plus 6 plus 6. It's the number 6 multiplied times 3. What is 6 times 3? Yeah, 18. Great! 6 times 3 equals 18. I'm getting a total of 18 cards. We can just double check that real quick. 6 times 3 means we have the number 6 3 times, which is the same as 6 plus 6 plus 6. 6 plus 6 equals 12. Yeah. And 12 plus one more 6 is 18. Yeah. 6 times 3 equals 18. Let's try another one. What is 8 times 1? What is 8 times 1? Yeah, 8. 8 times 1 equals 8. Now, why is that? Well, if you have the number 8 just one time, you just have 8. Actually, any time you multiply a number times 1, the answer is that number. Going back to bikes, you know that a bike has 2 wheels. If you have one bike, to find the total number of wheels using multiplication, you could multiply 2 times 1. 2 wheels, once. The number 2, just one time. And what's 2 times 1? Yeah, 2. 2 times 1 equals 2. If you multiply any number times 1, the answer is that number. For example, 9 times 1 equals 9. It's 9 just one time. 12 times 1 equals 12. It's the number 12 one time. 100 times 1 equals what? 100. It's 100 just one time. Great. Let's give this one a shot. 7 times 0. What do you think 7 times 0 is? Yeah, 0. But why is that? Well, if you have a number 0 times, you have 0. 7 times 0 equals 0. 7 times 0 means the number 7 0 times. The answer is 0. Whenever you multiply a number times 0, the answer is 0. 1 times 0 equals 0. It's the number 1 0 times. 5 times 0 equals 0. It's the number 5 0 times. 10 times 0 equals 0. What is 1 million times 0? You got it, 0. Awesome job. Aw, look at these puppies. Come over here, puppies. We're going to practice more multiplication. Come on. Hey, let's try this one. What is 4 times 2? What is 4 times 2? Yeah, 8. 4 times 2 equals 8. Great job. 4 times 2 is the number 4 2 times. This is the same as 4 plus 4. It's 2 4s, and 2 4s equals 8. 4 times 2 equals 8. Okay, let's try 5 times 3. What is 5 times 3? Yes, 15. 5 times 3 equals 15. Sweet! 5 times 3 is the number 5 3 times. This is the same as 5 plus 5 plus 5. It's 3 5s. 5 plus 5 equals 10, plus another 5 is 15. 5 times 3 equals 15. Next, let's try 1 times 4. What is 1 times 4? 4. Very cool. 1 times 4 equals 4. If you have the number 1 4 times, you have 4. You might have picked up on this already, but with multiplication, the order of what you are multiplying doesn't matter. The answer is the same. 4 times 1 equals 4. 1 times 4 equals 4. If you flip the 4 and the 1, the answer is the same. The answer is 4. I'll show you with pizzas, okay? Let's say there's going to be a big party, right? And a pizza place has a 4 pizza deal. It's a special deal that gets you 4 whole pizzas at a lower price per pizza. You get 1 4 pizza deal. It's 4 times 1. The number 4 once. 4 times 1 equals 4. So you have 4 pizzas. Now, if you flip the order and switch the 1 and 4, the answer is the same. See, this is the same as if you multiplied one pizza 4 times. That would be 1 times 4 equals 4. Both work. You can flip these numbers in multiplication, and the answer stays the same. Oh, it's question time. It's question time. I have a question for you. What is the answer to a multiplication problem called? What is the answer to a multiplication problem called? Yeah, the product. The answer to a multiplication problem is called the product. For example, 5 times 2 equals 10. 10 is the answer, so it's called the product. 0 times 6 equals 0. 0 is the answer, so 0 is the product. The answer to a multiplication problem is called the product. Let's go ahead and look at a few more. What is 3 times 4? What is 3 times 4? Yeah, 12. 3 times 4 equals 12. Phenomenal job! And as we just learned, 12 is the product. It's the answer to this multiplication problem. 3 times 4 means we have the number 3 4 times. It's the same as 3 plus 3 plus 3 plus 3. The number 3 4 times. 3 plus 3 equals 6. So each of these pairs equals 6. And what's 6 plus 6? Yeah, 12. That means 3 times 4 equals 12. Wow, we're in Egypt. That's pretty cool. That's pretty cool. Let's try 5 times 6. What is 5 times 6? What is 5 times 6? 30. Very cool. 5 times 6 equals 30. This is a big answer, isn't it? 5 times 6 is the number 5 6 times. To double check this, we can count by 5s. 5, 10, 15, 20, 25, 30. 5 times 6 equals 30. Great job! 30 is the product, the answer to this multiplication problem. Okay, here's the last one. What is 10 times 7? What is 10 times 7? Yeah, 70. Awesome! 10 times 7 equals 70. This can be illustrated using dimes because dimes are worth 10 cents. 10 times 7 means the number 10 7 times. Each dime is worth 10 cents, and there are 7 of them here. 10 times 7. To check our answer, we can count by tens. 10, 20, 30, 40, 50, 60, 70. 10 times 7 equals 70. 70 is the product. Wow, you did an incredible job learning about multiplication. I'm so proud of you. Next time you come across multiplication, you can get super excited just like this owl because you get it. You know how it works. Keep building up your skills. Multiplication is really cool, and so are you. Very cool. Fantastic job learning about multiplication. Okay, things are about to get wild and awesome because next we're going to learn about division. Division. Now, I know division might seem kind of tricky, especially if it's new to you, but it's really easy once you get the hang of it. Just ask this owl. He has a hat and everything, okay? You like division, owl? All right. I think the kids will too. But first, we need to find out, what is division? What is division? Well, division is when we split a number up by a certain number. Let's say there are 4 apples. Michael and Liam want to split the apples, and they want to make sure it's fair. There are 4 apples, and we are dividing the apples into 2 groups. One for Michael and one for Liam. 4 divided by 2. This symbol right here is the division sign. It shows us we're dividing. What is 4 divided by 2? Yeah, 2. That's right. 4 divided by 2 equals 2. If Michael and Liam are splitting these 4 apples, they each get 2. Check out this one. Let's say there are 6 bottles of water and there are 6 kids playing outside. That would be 6 divided by 6. If we split the 6 bottles by 6, how many water bottles does each kid get? 1. Great job. 6 divided by 6 equals 1. Everyone gets 1 water bottle. All right, next, let's practice division with school supplies. Let's say there are 9 brand new pencils that 3 students are going to split. 9 divided by 3. We're dividing the 9 pencils between the 3 students so that the students each get the same number of pencils. When we divide 9 by 3, how many pencils does each student get? Yes, 3. Great job. That means 9 divided by 3 equals 3. If you split 9 into equal groups of 3, there are 3 in each group. 9 divided by 3 equals 3. Awesome job. Before we practice more division, I want to ask you a quick question. What is the answer to a division problem called? What is the answer to a division problem called? The quotient. Yeah, the quotient. That's a cool word. Let's say that together. The quotient. Right. Can we say it one more time, just a little louder? The quotient. Yeah, the quotient. Okay, so we practiced 4 divided by 2, which equals 2. 2 is the quotient. We did 6 divided by 6, which equals 1. 1 is the quotient for that problem. And we just did 9 divided by 3, which equals 3. That means 3 is the quotient for that problem. The quotient is the answer to a division problem. And don't worry, Crab, we're going, okay? We have more division to do. Oh my goodness, it's somebody's birthday! Speaking of birthdays, here's a man celebrating his birthday with just 1 candle. I'm not sure what he's saying, but I like to think he's saying, "I put 1 candle on my cake." And she responds, "That's great. That's great." We're going to be dealing with more than 1 candle, though. In fact, imagine we have 7 candles. 7 of them. Now, in the other division examples, we divided a number into multiple groups. But in this example, we are only going to divide 7 by 1 because all of the candles are going on the same cake. 7 divided by 1. And the answer is super simple. How many candles does each group have? Well, there's just 1 group, and all 7 candles are on it. So the answer is 7. Yes, 7 divided by 1 equals 7. 7 is the quotient. Anytime you divide a number by 1, the quotient is that number because all of it is going into just 1 group. For example, 9 divided by 1 equals 9. It's 9 just getting put into 1 group. 40 divided by 1 equals 40. It's 40 getting divided into just 1 group. 1,000 divided by 1 equals 1,000. It's 1,000 divided into just 1 group. When you divide a number by 1, it's super simple. The quotient is that number. Whoa, look at these 2 bears. These 2 bears are going to share some fish. Okay, they're going to evenly divide some fish. Okay, whoa, bears. You both are friends. You both need to share these fish. Okay, evenly. We're going to divide them up. So there are a total of 10 fish, and we are dividing the 10 fish into 2 groups, 1 for each bear. 10 divided by 2. The quotient, the answer to the division problem, will tell us how many fish each bear gets. What is 10 divided by 2? Yeah, 5. Great. 10 divided by 2 equals 5. And you can see each bear gets 1, 2, 3, 4, 5 fish. 10 divided by 2 equals 5. Awesome job. Aw, hello doggies. Are any of you hungry? I'm asking because, well, I have good news for the 4 of you. We have dog biscuits for you to share. We just want to divide them evenly so each of you gets the same amount. We have 12 dog biscuits here, 12 of them, and there are 4 dogs. 12 divided by 4. We have to divide or split up the 12 dog biscuits into 4 equal groups. 12 divided by 4 will tell us how many dog biscuits each dog will receive. What is 12 divided by 4? 3. Great job! 12 divided by 4 equals 3. Each dog will get 3 dog biscuits. 12 divided by 4 equals 3. 3 is the quotient. You are doing an incredible job. Let's try this one next. How many people do you see here? 5. There are 5 people who have been playing outside and are going to take a quick snack break. Thankfully, they brought strawberries. They have 20 strawberries in all and want to divide them amongst each other. This will be fun. So there are 20 strawberries in all, and we are dividing them into 5 groups, 1 for each person. 20 divided by 5. What is 20 divided by 5? Yeah, 4. Awesome! 20 divided by 5 equals 4. That means each person gets 4 strawberries. 20 divided by 5 equals 4. 4 is the quotient. Great! Hey, I think it's time for a division fact. It's division fact time! When you have a division problem, the total number is called the dividend. The number of groups you are splitting it up into is called the divisor. And the answer, as we've already talked about, is called the quotient. Now, a cool thing about division is you can switch the divisor and the quotient, and the division problem remains true. For example, 8 divided by 4 equals 2, but also 8 divided by 2 equals 4. Interesting. The divisor and the quotient can be switched, and the division problem remains true. I'll show you with bananas. Bananas are so tasty! We have 8 bananas here. 8 divided by 4 equals 2. Dividing the 8 bananas into 4 groups means each group has, 2 bananas in it. Cool. Now, if we flip the 4, which is the divisor, and the 2, which is the quotient, it remains true. So 8 divided by 2 equals 4. If we divide the 8 bananas into 2 groups, we see there are 4 bananas in each group. That's pretty awesome. And speaking of awesome, the next example is from the world of tennis. Have you ever played tennis before? Okay. I enjoy tennis. It's a fun sport. Let's say there are a total of 16 tennis balls, and 2 tennis players want to split them up. 16 divided by 2. 16 divided by 2 will tell us how many tennis balls each player will get. What is 16 divided by 2? 8. There are 8 tennis balls in each of these 2 groups. 16 divided by 2 equals 8. Okay, so 16 divided by 2 equals 8. Now remember, the total we are dividing is called the dividend. The dividend is 16. The number of groups you are splitting it into is called the divisor. The divisor in this division problem is 2. And what is the answer to a division problem called? The quotient. Great job! The quotient in this problem is the number 8. Now, we learned that we can switch the divisor and the quotient and it remains true. Let's put that to the test with this. We'll try 16 divided by 8, which will be 2. Here are the 16 tennis balls again, but this time we'll divide them into 8 groups because the divisor is 8. In this case, 8 players are splitting the 16 tennis balls. How many are in each group? Uh-huh, 2. 16 divided by 8 equals 2. Fantastic job. So you really can switch the divisor and the quotient, and the answer remains true. That's really cool. Okay, let's look at a few final division problems. If you don't know the answer, that's all right. Division can take practice, and you'll learn a cool new division fact for next time. Here's the first one. 9 divided by 9. What is 9 divided by 9? Yes, 1. 9 divided by 9 equals 1. If you have 9 and divide them into 9 groups, there is 1 in each group. 9 divided by 9 equals 1. 1 is the quotient. Great job! Here's the next one. 14 divided by 2. What is 14 divided by 2? 7. 14 divided by 2 equals 7. If you have 14 and divide it into 2 groups, each group has 7 in it. 14 divided by 2 equals 7. 7 is the quotient. Fantastic. All right, here's the last one. What is 15 divided by 3? What is 15 divided by 3? Awesome! 5! Yeah! 15 divided by 3 equals 5. If you have 15 and divide it into 3 groups, each group has 5 in it. 15 divided by 3 equals 5. 5 is the quotient. You did such an amazing job. Even if you didn't know all of these, you are well on your way to being a division master. Aw, these cats are dividing up this food. The division owl would be proud. I am too. It's always impressive when pets learn how to do math too. Wow. Do you know how to do division, Mr. Whiskers? Do you know how to do division? You know what? We could talk after the video. Yeah, don't worry about it now. It's fine. All right. Whoa. Well done. Now that we've learned multiplication and division, it's time to learn how to multiply and divide larger numbers. I'm so excited about that. It's really cool. It's really cool. Next, we're learning about long multiplication. Yeah, long multiplication. Long multiplication is how we multiply larger numbers. To help us with long multiplication, we're going to get some help from our friend Clancy. Yeah, Clancy. You see, Clancy is going to have a big party. That's right. And he's going to need a lot of cupcakes. Clancy decides to buy 4 dozen cupcakes. How many are in a dozen? 12. That's right. To find out how many cupcakes he's buying, we need to multiply 12 times 4, because he's buying 4 dozen cupcakes. 12 times 4. Let's write down 12 times 4. We put 12 on top and 4 below it, making sure everything is lined up by place value. The 2 and the 4 are both in the ones place, so they line up perfectly. The number 1 is in the tens place. Because this 1 is in the tens place, it represents 1 single 10, so it really means 10. First, we'll multiply the ones, so we'll multiply 2 times 4. What is 2 times 4? 8. Yes, we put the number 8 here under the ones because we were multiplying the ones place. Wonderful. First step down. Next, we move over here to the tens place. We're going to multiply across. 1 times 4. Because we're multiplying the 10 spot, this is really 110 times 4. What is 1 times 4? Yep, 4. It's the number 4, 1 time. So we'll write the number 4 here in the tens place because we were multiplying the tens. And that's it. We have our answer. 12 times 4 equals 48. Clancy is ordering 48 cupcakes. Wow, 48 is the product. Hey, great job solving that. All we had to do was multiply the ones and then multiply the tens. Now let's try a few more to get used to this process. Here we have 21 times 3. We have the 21 on the top and the 3 below it. It's lined up by place value. The 1 and the 3 are in the ones place. The number 2 is in the tens place. First, we multiply the ones, so we'll multiply 1 times 3. What is 1 times 3? Yeah, 3. We'll put the number 3 here under the ones because we were multiplying the ones place. Awesome. Now we need to multiply the tens place. We're going to multiply across. 2 times 3. Because we're multiplying the 10 spot, this is really 2 tens times 3. What is 2 times 3? You got it, 6. So we'll write the number 6 here in the tens place because we were multiplying the tens. And that's it. We have our answer. 21 times 3 equals 63. 63 is the product. Fantastic. Next, let's try 42 times 2. We have the 42 on the top and the 2 below it. It's lined up by place value. Both 2's are in the ones place. The number 4 is in the tens place. First, we multiply the ones, so we'll multiply 2 times 2. What is 2 times 2? Yep, 4. Yes! We put the number 4 here under the ones because we were multiplying the ones place. And now we need to multiply the tens place. We're going to multiply across. 4 times 2. What is 4 times 2? 8. Tremendous job! So we'll write the number 8 here in the tens place because we were multiplying the tens. And that's it. 42 times 2 equals 84. 84 is the product. Let's do another one, but with a special twist. 57 times 2. We make sure it's lined up by place value and we're ready to go. First, we multiply the ones. What is 7 times 2? 14. Great, but 14 is a double-digit answer. What do we do? Well, we write the 4 down here in the ones place and put the 1, which is a 10, up here at the tens place. That's called regrouping. Regrouping. The 4 in 14 stays down here like we've been doing, and the 1 is carried up here. Then we multiply the tens. We do that by multiplying across 5 times 2. What is 5 times 2? 10, that's right. But we have this extra 10 that we carried over from 14 when we regrouped. All we do is add that extra 1 to the 10, which gives us 11. We write 11 down here, and we have our final answer. 57 times 2 equals 114. 114 is the product. Hey, let's practice regrouping with one more problem, and then we'll be ready to take things to the next level. How about 47 times 3? We make sure everything is lined up by place value, and we're ready to go. First, of course, we multiply the ones. What is 7 times 3? 21. Awesome! But 21 is another double-digit answer, but that's okay. This part is fun. We write the 1 down here in the ones place and put the 2, which represents 20, up here at the tens place. That's called regrouping. The 1 in 21 stays down here, and the 2 is carried up here with the tens. Then we multiply the tens. 4 times 3. What is 4 times 3? 12. Yes, but we have this number 2 that we carried over from 21 when we regrouped. All we do is add that 2 to the tens answer we got. That gives us 14, because 12 plus 2 equals 14. We write 14 down here, and we have our final answer. 47 times 3 equals 141. 141 is the product. You are doing an amazing job. Now you know everything you need to multiply two double-digit numbers. We'll take it one step at a time, and you'll see it's not as tricky as it looks. Let's start with 21 times 11. We write 21 on top and 11 right below it, lining it up by place value. And we're ready to go. Now, for the first steps, we aren't going to use this digit down here in the tens place. We'll need it later, but we'll have to wait. What I like to do is cover it up real quick. Let's hide it behind this owl. Why an owl? I don't know. I guess I just really like owls, you know? Now we do the same thing we did before. First, we multiply the ones. What is 1 times 1? 1. Yes, 1. We'll put the 1 down here below the ones. Next, we multiply the tens. To multiply the tens, we need to multiply across. 2 times 1. What's 2 times 1? 2. 2. So we put the number 2 down here below the tens. Great. At this point, we are ready for the digit behind the owl. We have to move this owl. Since we no longer need this digit in the ones place, we can just scoot the owl over here. Before we keep multiplying, we have one more thing to do. We need to put a 0 in the ones place right here as a placeholder. Since this 1 that we just uncovered is in the tens place, that means it's really 10. That's why we put a 0 here. What's next? Well, we multiply like we did before, except we are multiplying by this digit in the tens place. We multiply across 1 times 1. What is 1 times 1? 1. That's right, 1. We put the number 1 right here. And what is 2 times 1? 2. Yep, 2. We put the number 2 down here. We're almost done. Now all we have to do is add these answers together. We just have to add them up. 1 plus 0 equals 1, 2 plus 1 equals 3, yeah. And this final line just has the number 2. And we have our answer. 21 times 11 equals 231. 231 is the product. Amazing job. Oh, cool. The owl is chilling in a tree. I mean, this isn't the same owl from our multiplication problem. First of all, this owl looks different, and our multiplication owl is a cartoon, so there's that. Maybe they're cousins. Let's try another one. How about 62 times 20? We write the 62 on top and 20 right below it, lining it up by place value. And we're ready to go. Remember, for the first steps, we aren't going to use this digit down here in the tens place. We'll need it later, but we'll have to wait. Let's cover it up real quick with the owl again, all right? After covering that up, we multiply the ones. What is 2 times 0? 0. Yes. If you multiply any number times 0, the answer is 0. We'll put the 0 down here below the ones. Next, we multiply the tens. What is 6 times 0? 0 again. So we put another 0 down here below the tens. Awesome. At this point, we are ready for the digit behind the owl. Since we no longer need this digit in the ones place, we'll just scoot the owl over here like we did last time. Before we keep multiplying, we have one more thing to do. We need to put a 0 in the ones place right here as a placeholder. Since this 2 that we just uncovered is in the tens place, that means it's really 20. That's why we put a 0 here. Now we multiply like we did before, except we are multiplying by this digit in the tens place. We multiply across 2 times 2. What is 2 times 2? 4. That's right, 4. We put the number 4 right here. And what is 6 times 2? 12. Yep, 12. We put the number 12 down here. Awesome. We're almost done. All we have to do is add these answers together. Since the top row is just zeros, we can bring down the other numbers without changing them, because nothing is being added to them. We now have our final answer, 1,240. 62 times 20 equals 1,240. 1,240 is the product. Fantastic! You've done an incredible job learning about long multiplication. Long multiplication is how we multiply large numbers. Let's do one more example, going through it one step at a time, except with this last one, we will use regrouping, okay? The last one we'll do is 34 times 13. We write the 34 on top and 13 right below it, lining it up by place value. And we are ready to go. Remember, for the first steps, we aren't going to use this digit down here in the tens place. We'll need it later, but we'll have to wait. Let's cover it up real quick with the owl again. First, we multiply the ones. What is 4 times 3? 12. Awesome. Now 12 is a double-digit answer, so we will need to regroup. Do you remember how this works? We write the 2 down here in the ones place. And where do we put the 1? Yeah, up here. This 1 represents 10. That's why it goes up here in the tens place. That's called regrouping. The 2 in 12 stays down here, and the 1 is carried up here with the tens. Then we multiply the tens. 3 times 3. What is 3 times 3? 9. Yes, but we have this number 1 that we carried over from 12 when we regrouped. All we do is add that 1 to the tens answer we got. That gives us 10, because 9 plus 1 equals 10. We write 10 down here below the tens. Great. Now that we are done using it, we can remove this number 1 that we regrouped, because we are ready for the next step. What do we do next? Yeah, you know what? We've got to move the owl. We'll just scoot the owl over here like we've been doing. When you do this, you can use your finger to block it instead of this owl. Not everyone has a fancy cartoon owl to block digits with, okay? Now we have one more thing to do before we continue multiplying. We need to put a 0 in the ones place right here as a placeholder. Since this 1 that we just uncovered is in the tens place, that means it's really 10. That's why we put a 0 here. And now we multiply. We are multiplying by this digit in the tens place. We multiply across 4 times 1. What is 4 times 1? 4. That's right, 4. We put the number 4 right here. And what is 3 times 1? 3. Yep, 3. We put the number 3 down here. We're almost done. Now all we have to do is add these answers together. 2 plus 0 equals 2. 0 plus 4 equals 4, yeah. And 1 plus 3 equals 4. That's right. And we have our answer, 442. 34 times 13 equals 442. 442 is the product. Amazing. Great job. Remember, when we multiply double-digit numbers by double-digit numbers, we cover this digit here and multiply the ones and then the tens. Then we cover the digit here in the ones place. Don't forget the placeholder 0. Then multiply by this digit in the tens place, starting with the ones and then the tens. Finally, just add these answers together, and that's it. Now you know how to multiply large numbers. You did an amazing job practicing long multiplication today. Keep practicing and soon you'll be able to solve even bigger long multiplication problems because I know you have what it takes. Great job learning long multiplication. Wow, I'm impressed. This dog is impressed too, I think. Are you? All right. Well, I'm impressed. You know how we learned how to divide earlier? Just like we multiplied bigger numbers with long multiplication, we're going to divide bigger numbers too. That's called long division. It's time to take things to the next level. We're going to learn how to divide larger numbers using long division. We'll start really simple and build up from there. It's going to be fun. First, we're going to look at 48 divided by 4. 48 divided by 4. When we do long division, we use this thing right here. It's called the long division bracket. Oh, that's a long name. The long division bracket. This is how we set up a long division problem. We put the dividend, that's the big number we're splitting up, inside the bracket right here. The dividend in this problem is 48. The divisor, which is 4 in this problem, goes right here, right in front of the bracket. It's always set up this way. The dividend goes inside the long division bracket, and the divisor is placed out in front. That's a pretty cool setup. Hey, let's set up 48 divided by 4 again. We start off with the long division bracket. We put the dividend, which is 48, inside the bracket. Then we put the divisor, which is 4, right in front of the bracket, and we're ready to go. We're going to start with the first digit inside the bracket, the 4 in 48. We are going to divide. How many times does 4 go into 4? Yeah, 1 time. So we write a number 1 on top of the bracket right above this 4. Next, we're going to do something interesting. We're actually going to multiply this number 1 times the divisor. What is 1 times 4? 4. Yes, we put that answer, the number 4, right here, underneath the 4 in 48. So far, so good. Then we subtract these 2 digits right here. What is 4 minus 4? 0. That's right. So we put a 0 here. Since we have this extra digit, the number 8, we'll bring it down. Do you see this 0 here? You don't have to worry about it. Even though it looks like 08, that's the same as 8. The 0 doesn't change the number. We're just working with the 8. Then we repeat the whole process again, except we divide this digit here, the number 8. We're going to divide again. How many times does 4 go into 8? 2. Yeah. So we put the number 2 on top of the bracket, next to the 1, and right above the 8. Next, we multiply again. This number 2 times 4. What is 2 times 4? 8. We put that answer, the number 8, right here under this 8. Then we subtract. 8 minus 8 equals 0. Yeah, and there's nothing left to bring down, so we're done. And we have our answer, the quotient. The answer to this division problem is up here above the bracket. It's 12. 48 divided by 4 equals 12. That might seem like a lot of steps to remember, but there's a trick to learn them. To do long division, all we have to do is divide. Multiply, subtract, bring down. Divide. Multiply, subtract, bring down. First, divide. 4 goes into 4 1 time. Second, multiply. 1 times 4 equals 4. Third, subtract 4 minus 4 equals 0. Fourth, bring down the 8. Then we repeat the steps with this digit here. Divide, 4 goes into 8 2 times. Multiply, 2 times 4 equals 8. Subtract, 8 minus 8 equals 0. And there's nothing else to bring down, so we're all done. The quotient, the answer to the problem, is 12. The 4 steps in long division are divide, multiply, subtract, bring down. Let's try another one, okay? How about 93 divided by 3? That would be fun. Let's set up 93 divided by 3. We start with the long division bracket. We put the dividend, which is 93, inside the bracket. That's the big number we're splitting up. Then we put the divisor, which is 3, right in front of the bracket. The divisor is the number of groups we're splitting the dividend into. All right, we're ready to go. Remember, the first step is to divide. We're going to start with the first digit inside the bracket, the 9 in 93. How many times does 3 go into 9? Yeah, 3 times. So we write a number 3 on top of the bracket, right above this 9. Next, multiply. We multiply this number 3 times the divisor. What is 3 times 3? 9. Yes, we put that answer, the number 9, right here underneath the 9 in 93. Great. Next, subtract. We are going to subtract these 2 digits right here. What is 9 minus 9? 0. That's right. Since we have this extra digit in the dividend, it's time to bring down. We'll bring down the number 3. That's awesome! Okay, now it's time to go through the steps again with this digit here, this number 3. Divide! How many times does 3 go into 3? 1 time, yeah. So we put the number 1 right here on top of the bracket. Next, we multiply again. This number 1 times 3. What is 1 times 3? 3. We put that answer, the number 3, right here under this 3. Then we subtract. 3 minus 3 equals 0. Yeah. And there's nothing left to bring down, so we're done. Well, we have our answer, the quotient. The answer to this division problem is up here above the bracket. It's 31. 93 divided by 3 equals 31. To do long division, all we have to do is divide, multiply, subtract, bring down. Wow, cute guinea pig. What if this guinea pig was listening and can now do long division? Nah, maybe. All right, let's try another one. But this time, something a little different is going to happen. Let's see what happens when we try 74 divided by 6. Will it split up evenly, or will there be something left over? Let's find out. Here's the setup. We have the dividend, 74, inside the long division bracket, and the number 6, which is the divisor, is right in front of the bracket. We're ready to go. Remember, the first step is to divide. We're going to start with the first digit inside the bracket, the 7 in 74. How many times does 6 go into 7? Yeah, 1 time. So we write a number 1 right here on top of the bracket. Next, multiply. We multiply this number 1 times the divisor. What is 1 times 6? 6. Yes, we put that answer, the number 6, right here underneath the 7 in 74. Fantastic. Next, subtract. We are going to subtract these 2 digits right here. What is 7 minus 6? 1. That's right, we'll put a 1 here. Now, since we have this extra digit in the dividend, it's time to bring down. We'll bring down the number 4. Awesome. Okay, time to go through the steps again with this number down here, 14. Divide. How many times does 6 go into 14? 2 times. Yeah. So we put the number 2 right here on top of the bracket. Next, we multiply again. This number 2 times 6. What is 2 times 6? 12. We put that answer, the number 12, right here under this 14. Then we subtract. 14 minus 12 equals 2. Yeah. And there's nothing left to bring down, so we're all done with the steps. Notice, instead of a 0 down here like we've been seeing, there's a number 2. This is called a remainder. A remainder. 74 can't be evenly split up into 6 groups. There are 2 left over. 2 is the remainder. We write R2 up here because there is a remainder of 2. That's pretty nifty. And we have our answer, don't we? The quotient is 12 with a remainder of 2. 74 divided by 6 equals 12 with a remainder of 2. Amazing job. All right, we're going to look at one last long division problem. In this final example, we're going even bigger. Okay, even bigger. We're going to divide a triple digit number. Okay, let's do 126 divided by 5. 126 divided by 5. Okay, here's the setup. We have the dividend 126 inside the long division bracket, and the number 5, which is the divisor, is right in front of the bracket. We're ready to go. Remember, the first step is to divide. We start by looking at the first digit inside the bracket, the 1 in 126. How many times does 5 go into 1? Wait, it doesn't. 5 is too big to fit into 1, even one time. So what do? Well, when the divisor doesn't fit into the first digit, we look at the first 2 digits together. That means we try the number 12. That's pretty cool. All right, how many times does 5 go into 12? Yes, 2 times. So we write the number 2 up here, right above the second digit in the dividend, the 2 in 126. Then we multiply. We multiply this number 2 times the divisor. What is 2 times 5? 10. Yes. We put that answer, the number 10, right here underneath the 12 in 126. Awesome. Next, subtract. What is 12 minus 10? 2. That's right. We'll put the number 2 right here. Great. Since we have this extra digit in the dividend, it's time to bring down. We'll bring down the number 6. This number down here is now 26. Very cool. All right, time to go through the steps again with this number down here, 26. So we divide. How many times does 5 go into 26? How many times does 5 go into 26? 5 times. So we put the number 5 right here on top of the bracket above the 6 in the dividend. Next, we multiply again. This number 5 times the divisor, also the number 5. What is 5 times 5? 25. Yes, we put that answer, the number 25, right here under this 26. Then we subtract. 26 minus 25 equals 1. Yeah, and there's nothing left to bring down, so we're all done with the steps. We have a remainder again, don't we? Instead of a 0 down here, there's a 1. This is called a remainder. 126 can't be evenly split into 5 groups. There's 1 left over. 1 is the remainder. We write R1 up here because there is a remainder of 1. And we have our answer. The quotient is 25 with a remainder of 1. 126 divided by 5 equals 25 with a remainder of 1. Aw, here's the guinea pig again. The 4 steps in long division are divide, multiply, subtract, bring down. When we start, we always try to divide the first digit of the dividend. But if the divisor doesn't fit, like in our last example, we look at the first 2 digits instead. And sometimes when we finish dividing, there's a number left over. That's called a remainder. We write the remainder up here next to the quotient with the letter R to show that the dividend didn't divide evenly. And that's how long division works. You did an amazing job practicing. Keep it up, and soon long division will be as easy as pie, as easy as apple pie. You know what? That looks yummy. That looks very delicious. Awesome. You did a terrific job. Long division. Wow. Very cool. Now we're going to switch it up, right, Mr. Whiskers? We're going to switch the topic. Okay. All right. I thought I'd include you. Okay. We're going to learn about something really awesome about numbers. Place values. We're learning about place values next. You might have noticed I talked about 1s and 10s when we were learning double-digit math. Those are place values. Place values. Let's take some time right now to learn more about place values. But to do that, we need to learn this word right here. Digits. Digits. So, what are digits? Digits are the parts of a number. Like, look at the number 920. There are 3 parts, or digits, in this number. The number 920 has 3 digits. Remember, digits are the parts of a number. Pretty simple. Let's look at the number 74. There are 2 parts, or digits, in the number 74. The number 74 has 2 digits. Remember, digits are the parts of a number. Super simple, super easy. And finally, let's look at the number 6. How many digits are in the number 6? Remember, we're just looking at the parts of the number. How many digits? Yeah, just 1 digit. There's only 1 part or digit to this number. It's just 6. Great job! Remember, digits are the parts of a number. Okay, so this is awesome. Here is where place values come in. The place value is how much a digit is worth based on where it is. In other words, where a digit is in the number tells us how much it is worth. So, what are the place values we're going to be looking at today? What are the different values of the places where the digits will be? Well, the digits will either be in the 1s spot, the 10s spot, the 100s spot, or the 1000s spot. Alright, let's use the place values. Okay, so here are the place values and where they are for the different digits. This first spot is the 1s spot. That's where the 1s go. This second spot is the 10s spot. It's where the 10s go. This third spot is the 100 spot. It is where the 100s go. And finally, here is the 1000s spot. It is where the thousands go. Now the place values can go higher than this, but these are the only place values we're going to be learning about today. Alright, so our first example is the number 4,000. The number 4,000. Alright, well I'm going to need your help. Which digit is in the ones spot? You can see it right there. Which digit is in the ones spot? Yeah! 0! Great job! Alright, how about helping us figure out the tens? Which digit is in the tens spot? Yeah! 0! Good job! All you have to do is look where the arrow is pointing. The 10 spot is a 0. Alright, how about the hundreds spot? Which digit is in the hundreds spot? You see? Yeah, the same answer, 0. Good job, good job. Okay, and which digit is in the thousands spot? Which digit is in the thousands spot? Yeah, 4. Awesome. The number 4 is in the thousands spot. There are 4 thousands in the number 4,000. Alright, our next example is the number 508. Okay, I'm going to need your help again. Which digit is in the ones spot? You can look at the place values for a clue. You can see the arrow. Which digit is in the one spot? Yeah, 8. Good job. Okay, which digit is in the tens spot? Which digit is in the 10 spot? Yeah, 0. Good job. Alright, which digit is in the hundreds spot? Can you see that? Which number is in the hundreds spot? Yeah, 5. Good job. Okay, now this might seem a little tricky. Which digit is in the thousands spot? Which digit is in the thousands spot? Wait a second, there isn't even a digit there. It's only 508. There are no thousands. So the digit would be nothing or 0. 0 and nothing, it has the same value. So there's nothing that's in the thousands spot. It's only 508. There are no thousands. You are doing a phenomenal job. Okay, now you're going to be able to give it a try without any help or any clues. And you've learned so much. I think you can do it. I think you can do it. You're going to do awesome. Okay, you're ready. Here's the number. 8,763. 8,763. We're going to name the place values, and you let us know which digit is in which one. Okay, which digit is in the one spot? Which digit is in the one spot? The number's 8,763. Which one? Yeah, 3. 3 is in the one spot. Remember, this is the one spot. Good job. Okay, what's in the 10 spot? Which digit is in the 10 spot? 6. 6 is in the 10 spot. Good job! Yeah, you can see right here is where the 10 spot is. Wow, you're getting the hang of it. Okay, which digit is in the 100 spot? Do you know which one? Which digit is in the 100 spot? 7. Way to go! Yes, 7 is in the 100 spot, and you can see right here is that 100 spot. Yeah! 7 is in the 100 spot. Good job! Okay, here's the last one. Which digit is in the thousands spot? Which digit is in the thousands spot? 8. Yes, good job. 8 is in the thousands spot. And you can see right here is where that thousands spot is, just before that comma. Isn't that awesome? Wow, you've learned so much. To review, digits are the parts of a number. The place value is how much a digit is worth based on where it is. These are the place values we learned today, the ones, tens, hundreds, and thousands. In this example, there are 3 ones, there are 6 tens, which is 60, there are 7 hundreds, which is 700, and there's 8 thousands. So the number read out is 8,763. It's so nice going for a stroll and just thinking about those place values. Oh, I love the ones and the tens and the hundreds and the thousands. Knowing where a digit is tells us what the value is, which is great. Very, very cool. Place values. Great job with that. All right, we're moving right along. It's been awesome. Now we're going to look at a classic math lesson. Next, we're going to learn about even and odd numbers. Even and odd numbers. Even and odd is actually pretty easy, but it's just a matter of knowing what to look for. So we're going to be like detectives together, okay? You're going to have an eagle eye. To help us out on our quest, we're going to use dinosaurs. Dinosaurs are awesome. And here's a red dinosaur that's, I don't know why it's windy. There's wind going on, and I don't know let's change the scenery. Let's make it more modern day. There you go. Look at that. Just walking through the neighborhood, strolling. He's ready to help us discover the secret, right? To knowing even and odd. So what is this key that we're looking for? What are we looking for that will tell us if a number is even or if the number is odd? An even number can be grouped by 2. An odd number cannot be evenly grouped by 2. So it's all about the number 2, and that might sound confusing. Let me show you and you'll see. Here is the easiest number to do. We're looking for the number 2, okay? Can it be put in a group of 2? Well, yes, because it's the number 2. We've got 2 dinosaurs. That makes 2 even. Now this is odd. This dinosaur's all alone. He's not in a group of 2. This makes the number 1 an odd number because he's all alone. That's odd. It's an odd number. Let's look back at the number 2. See, what's neat about this is it's an even group of 2. That means our dinosaur has a friend. He can talk to his friend. He can hang out. It's not weird. It's not odd. It's an even number. Here we have 3 dinosaurs. Now, can we put the number 3 in even groups of 2? Well, no, because that third dinosaur is all alone. The top 2 dinosaurs have somebody. 3 is odd. There's one that's missing a partner. Here we have 4 dinosaurs. Now we're looking for groups of the number 2. Now we have 2 groups of 2 here. That means it's an even number. Each dinosaur has a friend. Wow, 5 dinosaurs. But look, one on the bottom doesn't have a pal, doesn't have a friend. That's odd. It's not evenly grouped into 2. 5 is an odd number. Hey buddy, okay, don't run, okay? We'll get back to the even numbers. I know you don't like the odds, you don't like being the odd dinosaur out. It's okay. I promise this next number is going to be even because it goes for even, odd, even, odd. Just hang on. Oh, man, dinosaurs, so temperamental, I mean, what's that all about? I mean, a dog wouldn't have done that, dogs are better, I think, now than dinosaurs, I'm just kidding. Dinosaurs are so cool. Moving on. Here we have 6 dinosaurs. Now, each dinosaur has a friend. That means 6 is even. You can split it up in groups of 2. Oh, here we have 7 dinosaurs, but there's one dinosaur that's all alone. 6 of them have friends, but one is all alone, doesn't have a pair. 7 is odd. The number 8. Does everyone have a friend? Yes! There's no one without a friend. Number 8 is an even number. It splits up into 2 very nicely. 8 is even. Let's go even higher, the number 9. Now you can see really quick, it's easy to spot. Is 9 even or odd? Yes, it's odd. There's one who doesn't have a friend. 9 is odd. Oh my goodness, 10. 10, is it even or is it odd? You tell me, you know how to do it now, you know the trick. Yes, 10 is even. Everybody has a friend. Now we're about to teach you 2 sneaky tricks that you can use with even and odd numbers, okay? So seriously, it's not really sneaky, but anyway. So this first trick is that all of the numbers alternate from odd to even and back, and we're going to show you what that means and what that looks like. Here we have the first 10 numbers, numbers 1 through 10. And the trick was, all of the numbers alternate from odd to even and back. Do you remember if number 1 is odd or even? Yes, number 1 is odd, because remember, number 1's all by himself, doesn't have a friend, doesn't have a partner, it's not an even number. Number 1 is odd. Now, we remember number 2, right? Number 2 is even. Yes, because it can be grouped in 2, because it is 2. Now, if they alternate, that means which one is number 3? It's odd. This is where it gets fun. If 3 is odd, then that means 4 is even. Good job. And if 4 is even, that means 5 must be odd. Yeah. And if 5 is odd, that means 6 must be, you guessed it, even. And if 6 is even, that means 7 must be odd. Yes, 7 is odd. If 7 is odd, that means 8 is, come on, what's the pattern? 8 is even, and if 8 is even, that means 9 must be odd, and if 9 is odd, come on, is this not just the most fun trick ever? If 9 is odd, that means 10 is even. They all alternate. So the first trick is that they alternate, the numbers alternate. Odd, even, odd, even, odd, even, odd, even, odd, even. Now, we're going to look at the second trick. The second trick is that with numbers bigger than 10, if it's odd or even, you can see on the end. With numbers bigger than 10, if it's odd or even, you can see on the end. As you can see, 10 on the bottom ends in 0 and it's even. Every single number that ends in a 0 is even, just like every number that ends in a 1 is odd. Every number that ends in a 2 is even. Every number that ends in a 3 is odd, because 3 is odd. Every number that ends in a 4 is even. And it goes on and on. Numbers that end in 5 are odd. Numbers that end in 6 are even. Numbers that end in 7 are odd. Numbers that end in 8 are even. Numbers that end in 9 are odd. And then numbers like 10 that end in 0 are always even. So there you go. odd, and even. As long as you learn these, you'll know any number because the endings always tell you if it's odd or even. So once you know these, you'll know all of them. Whoa, well done! You know even and odd numbers. Okay, we just looked at place values and even and odd numbers. Now we're going to learn about something very interesting called positive and negative numbers. Hey, have you ever heard of positive and negative numbers? Numbers can be positive or negative. That's what we're going to learn about. What makes a positive number positive and what makes a negative number negative? And what are some real-life examples of positive and negative numbers? Hold tight, we're going to explore all of these questions and more, starting with this. Do you know what this is called? Yeah, it's called a number line. A number line. Which makes sense, it's a line and it has numbers on it, right? A number line is almost like a map of numbers. Numbers always go from least to greatest on a number line. On this number line, what number is in the middle? Yeah, 0. The number 0 is in the middle of this number line. Since number lines move from the least to the greatest number, every number gets bigger as we move down the line. So 1 is bigger than 0, which we know. If you have 1 pancake, that's more than if you have no pancakes, right? I mean, no pancakes, that would be so sad. 1 is greater or bigger than 0. 2 is bigger than 1. 3 is bigger than 2. 4 is bigger than 3. You get the idea. Now, if we move the opposite direction on the number line, every number gets smaller. Yeah. Now, here's something interesting. 0 is not the smallest number. Numbers can go lower than 0. I mean, 0 is in the middle of this number line, which means all of these numbers are less than 0. Numbers that are less than 0 are called negative numbers. Negative numbers, that's what they are. Now, you might have noticed each of these negative numbers has a negative symbol right in front. That's true for all negative numbers, so they're really easy to spot. So numbers that are less than 0 are called negative numbers, which makes sense. They have this negative sign in front of them. Numbers that are greater than 0 are called positive numbers. Positive numbers. They are easy to spot too. Just look for numbers that don't have a negative sign in front of them. So numbers that are less than 0 are called negative numbers, which makes sense. They have this negative sign in front of them. Numbers that are greater than 0 are called positive numbers. Yeah, positive numbers. They are easy to spot too. Just look for numbers that don't have a negative sign in front of them. Let's talk a little bit more about positive numbers. Positive numbers are very common, very common. We see them everywhere. So much so that the main way we write positive numbers is just to write the number all by itself. You can put a positive sign in front of a positive number if you'd like, but you don't have to. Most of the time, it's just the number. Positive numbers, negative numbers. Pretty simple. Wait, what about 0? Is 0 positive, negative, or neither? Well, neither. 0 is actually the only number that isn't positive or negative. It's kind of in the middle of all of them in its own category. 0. It isn't positive or negative. It's, 0. Hey, we use positive numbers a lot, right? We see them all around us, but when do we use negative numbers? Numbers that are less than 0. Check this out. This is footage from Antarctica, the 5th largest continent in the world. What do you think the temperatures are like there? Yeah, super cold. At the South Pole, which is in Antarctica, the temperature can be as low as negative 100 degrees Fahrenheit in the winter. Negative 100 degrees. Wow. If you live in an area that gets really cold temperatures, maybe you've experienced how cold it is when the temperature reaches negative degrees, negative numbers. Wow, numbers so low, they dip below zero. Me, I live in South Carolina, so yeah, the temperature is always in positive numbers here. I don't know what negative temperatures feel like. I can only imagine. Another example of negative numbers is when we look at the elevation of different places on Earth. The elevation of a place is its distance above or below sea level. Now, what's sea level? Well, sea level is how we measure how high or elevated a place is compared to the average height of the surface of the Earth's oceans. Now, if a place is lower than sea level, its elevation is a negative number. For example, a place called the Dead Sea is at negative 1,407 feet. Negative 1,407 feet. In North America, there's a place called Badwater Basin. Badwater Basin. If you are at Badwater Basin, you are at negative 282 feet. That means you are 282 feet below sea level. Of course, elevations can be positive numbers, and most places on land are above sea level. Where I live, I'm at 39 feet, meaning I'm 39 feet above sea level. If you're curious about what the elevation is where you live, you can ask a parent or teacher. It's kind of fun to find out. All right, the last example of negative numbers is if you owe someone money. Debt or money that's owed uses negative numbers. For money you get, you would use positive numbers. Okay, you know what? It's time to review. Numbers below zero are called... Yeah, negative numbers. Great job. Numbers above zero are called... Got it, positive numbers. Awesome. And zero, is it positive, negative, or neither? Do you remember? It's neither. Zero is its own thing. Wow, you really know your stuff. Well, that's what positive and negative numbers are. Keep a lookout for them, especially those negative numbers. They are more rare to spot in the wild. Great job learning about positive and negative numbers. That was really cool. Oh, hey, Beaver. Just saying hello. I'm saying hello to you and the kids, of course, okay? And... you know what? I hope you're ready for fun and adventure because you're about to learn about fractions. It's fraction time! I love fractions because they make me think of pizza. Yeah, pizza. You see, a fraction is a way to show a part of a whole. And a whole pizza is usually way too big for one person to eat alone. People usually eat just a part or a fraction of a pizza. I'll show you how it works with this pizza here. The pizza is cut into 4 equal slices. That means the whole pizza is now in 4 parts. If I eat 1 slice, that means I ate 1 out of 4 slices. That's written like this: 1/4. 1/4. I ate 1/4 of the pizza. The top number shows how many pieces I ate. Just 1. And the bottom number shows how many pieces the whole pizza was cut into. 4. 1/4 is a fraction. A fraction is a way to show a part of a whole. Let's look at 1/4 again. The top number, this number 1, is called the numerator. The numerator shows how many parts you have. The bottom number, the number 4 in this case, is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. Let's look at another one. This is a fraction you might have seen before. It's called 1/2. What if I had a smaller pizza and I decided to split it right down the middle to share with a friend? It's only cut into 2 equal slices or parts. If I eat one of those slices, I've eaten 1 out of 2, which is 1/2. This top number, the 1, is the numerator. It tells us how many slices I ate. This bottom number, the 2, is the denominator. It tells us how many equal parts the whole was cut into. Uh-oh, looks like someone wants the other half. Sorry, buddy, I already promised it to someone else. Plus, pizza isn't for dogs. Yeah, maybe we can find you some dog treats, you know? What are you gonna do, right, Mr. Whiskers? Yeah, we should probably go back to talking about fractions. Okay, check this one out. This time, I'm cutting the pizza into 3 equal slices. If I eat 1 slice, that's 1 out of 3. That's called 1/3. 1/3. The top number, the numerator, is 1, because I ate 1 slice. The bottom number, the denominator, is 3, because the whole pizza was cut into 3 equal parts. I ate 1/3 of the pizza. You know what? I've had a lot of pizza here, all right? And I get it, okay? But may I please just get a carrot, okay? I need carrots. Please, carrots. Okay, I feel better. Now, you know how the top number in a fraction is called the numerator and the bottom number is called the denominator? Well, I have a trick to remember that. When I think of fractions, I think of North Dakota. You know, the state. North Dakota. ND. It helps me remember that the numerator is on top and the denominator is on the bottom. North Dakota. I hope you don't mind. You've helped me through the years with fractions. Thank you, North Dakota. The numerator is on top. The denominator is at the bottom. North Dakota, ND. That's pretty cool, you know? Okay, now that we've seen how fractions work, it's time for a game. I'm going to show you some shapes. Each one will have 2 different colors. Your job is to figure out what fraction of the shape is red, okay? Look closely at each shape, count the parts, and try to say the fraction out loud before I show you the answer. Are you ready? All right, we'll start with a simple one. What fraction of this triangle is red? What fraction of this triangle is red? Yeah, 1/2. Half of the triangle is red. Great. The numerator shows us how many parts are red. Just 1 part is red. The denominator shows us how many total parts the triangle is split into. The triangle is split into 2 equal parts. Awesome job! Okay, what fraction of this square is red? Remember to count how many pieces are red, and then how many total pieces there are. What fraction of this square is red? 3/4. 3/4 of the square is red. Tremendous! The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the square is split into. The square is split into 4 equal parts. It's split into fourths. 3 out of 4 parts are red. That means 3/4 of the square is red. Very cool. You're getting the hang of this. Fractions. Whoa, that's That's a big piece. That's going to make someone very happy. Oh, it's not as big now. Okay. Well, that makes sense. That makes sense. It's just not as big of a fraction as I thought it was going to be. You know what? Let's check out another one. What fraction of this circle is red? What fraction of this circle is red? Yes, 2/3. 2/3 of the circle is red. Fantastic. The numerator shows us how many of the parts are red. 2 of the parts are red. And the denominator shows us how many total parts the circle is split into. The circle is split into 3 equal parts. 2 out of 3 parts are red. That means 2/3 of the circle is red. Great job. You know what? We only have 2 more. Isn't that great, ducks? Where are you going? You're swimming away? You're not even going to give them a try? Wow, I don't know. I thought you could practice fractions too. Well, maybe next time. Okay, here's the next one. What fraction of this rectangle is red? What fraction of this rectangle is red? Yes, 4/5. 4/5 of the rectangle is red. Awesome! The numerator shows us how many of the parts are red. 4 of the pieces are red. The denominator shows us how many total parts the rectangle is split into. The rectangle is split into 5 equal parts. 4 out of 5 parts are red. That means 4/5 of the rectangle is red. Wonderful job. All right, here is the last one. I know you've got this. What fraction of this circle is red? What fraction of this circle is red? Yes, 3/8. 3/8 of the circle is red. Very cool. The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the circle is split into. The circle is split into 8 equal parts. 3 out of 8 parts are red. That means 3/8 of the circle is red. You did an amazing job learning about fractions. A fraction is a way to show a part of a whole. The top number of a fraction is called the numerator. The numerator shows how many parts you have. The bottom number of a fraction is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. And now you've got some good fraction practice under your belt. Keep up the great work. You'll be a fractions master in no time. Very cool. You did great. Fractions. Well, we're going to continue to learn about parts of a whole with this next lesson because next we're learning about decimals. Yeah, decimals. Do you know what these are? Yeah, bouncy balls. I love bouncy balls. I do. Uh-oh, the bouncy balls are coming into the hallway, and they can't even read this wet floor sign. Oh, wow, the bouncy balls are coming down the stairs? Oh my goodness, they're taking over the building. They're taking over the building. Oh, Mr. Whiskers, am I glad to see you? That must have been a dream. But bouncy balls are really cool, and they don't cost much. In fact, a lot of times you can buy a bouncy ball for less than $1, okay? What a deal! Let's say you're in a toy store and you see that bouncy balls cost 50 cents each. This is what it looks like when you write out 50 cents. Here's the dollar sign. You know, we're talking about money in this example, right? There's a zero next to the dollar sign because it isn't even a full dollar. It's less than a dollar, so it has a zero here. Then we have something called a decimal point. A decimal point. Then there's a 5 and a 0 because it costs 50 cents. This is a great example of something called decimals. Decimals! We're going to learn a lot about decimals in this video. First, I'll show you some decimals so you know what they look like. 0.5, 1.3, 0.25, 4.5. What do all of these decimals have? Yeah, they all have this point called a decimal point, just like we had when we wrote out 50 cents. Decimals have this point called a decimal point. When you see that point, you know you're dealing with a decimal. And that's awesome, because decimals are super cool. They're able to show us numbers that aren't whole numbers. Let's imagine you have one donut, okay? Exactly one donut. We don't have to use a decimal point. One is a whole number. You have one donut. But let's say someone gives you another half. Wow, you don't have just one donut anymore. You have more than that, right? You have 1.5 donuts. If you write that as a decimal, you have 1.5 donuts. 1.5 is the same as 1.5. 1.5. You have one full donut, then you received another half, 0.5. You have 1.5 donuts. I have one donut. If I stare at it long enough, maybe another half will appear, and then I will have 1.5 donuts. Check this out. Here we have part of a lemon, half of one to be exact. That means we have 0.5 lemons. 0.5 is the same as 1/2. Wow, apples! Apples are great! Look at all of these apples! Let's say we have this many apples, and we want to show how many we have without using fractions, okay? Because this is the decimal video, right? We're going to use decimals. First, how many whole apples do we have? Yeah, 2. That's right. But we don't have exactly 2 apples, right? There's this other half. It's time to use decimals. Let's put the decimal point next to the 2 because we aren't done. We still have this half here. In total, we have 2.5 apples. That's right. 2.5 apples. Because with decimals, 0.5 is the same as 1/2. We have 2.5 apples. That's the power of decimals, kids. The power of decimals. Oh my goodness, look at all of these coins falling on a table. You know, coins are a great way to practice decimals. Do you know what type of coin this is? Yep, a dime. That's right, a dime. Now, how much is a dime worth? 10 cents. A dime is worth 10 cents. This is how we write 10 cents. We have the dollar sign because we're talking about money. Then we write 0.10. 10 cents. A dime is less than a dollar, which is why we have the 0 here. When you just have a dime, you don't have a full dollar yet. In fact, you would need 10 dimes to have a dollar. 10 of them. A dime is 1/10 of a dollar. 0.1 is the same as 1/10, and as we learned earlier, 0.5 is the same as 1/2. Oh wow, this man is taking his dog shopping. Fido, would you like this? No? Okay. Would you like this bone? No? You know, Fido, this is kind of what they have. They have a lot of options. We might be here for the rest of the decimal video. While he looks for dog food, notice when we talk about cents, we have this extra 0 here, okay? 10 cents and 50 cents both have these extra zeros. But 0.10 and 0.1 have the same value, just like 0.50 and 0.5 have the same value. We just include that extra 0 because we are showing 10 cents here and 50 cents here. Okay, so this circle shows us 0.5, or 1/2. This circle shows us 0.1, or 1/10. It's evenly split into 10 parts, and only one part is colored in, 0.1. Check this out. We're about to play with decimals and circles. Mr. Whiskers, I'm singing again. I'm singing songs again. All right, let's get started. What decimal does this show? There are 10 equal parts, and just one is colored in. Yeah, 0.1. Terrific. Wait, a second part is colored in now. What decimal do you think this shows? 0.2. That's right, 0.2. Okay, whoa, we're going higher. How about now? What decimal does this show? 0.3. You're getting the hang of this. 0.3. Great job. You know what? Let's go ahead and color another part. What is this decimal? 0.4. Very cool. 0.4. Awesome. We've almost colored in half of this circle. Almost. Now, if we color in just one more part, what is this decimal? 0.5. Yes! Which is the same as 1/2. Half of this circle is now the color red. 0.5. Well done. Wait. Stop the music. It's this dog's birthday. I was thinking of stopping after 0.5, but in honor of this dog, this little doggy's birthday, I feel like we should keep going. I don't even know what this dog's name is. Maybe it's Cheese Nugget, who knows? And Fido is still looking for food. But in honor of Cheese Nugget's birthday, or whatever this dog's name is, let's keep going. Are you ready? So this is 0.5. It's exactly 1/2. 0.5. If we color in one more tenth, what is this decimal? 0.6. Nice. 0.6. Whoosh! Another part was just colored in. What decimal does this show? 0.7. You got it. 0.7. We're just 3/10 away from having a full red circle. Okay, another one has been colored in. What decimal is this? 0.8. Right, 0.8. That means we are just 2/10 away from a full red circle. Let's go ahead and color in another tenth. What is this decimal? 0.9. Terrific job. 0.9. We are so close to a full circle. We are just 1/10 away. I think we're ready. All right, I think we're ready. Let's fill it in. What do we have? 1. We have one full red circle. Amazing job. Real quick, I want to check in on Fido. How is the shopping? Still looking? That's cool. Let's go ahead and learn decimals with another coin. Do you know what type of coin this is? Yeah, a quarter. Do you know how much a quarter is worth? 25 cents. Fantastic. 25 cents. This is how we write 25 cents. We have the dollar sign because we're talking about money. Then we write 0.25. That's 25 cents. Now, do you know how many quarters you need to have a full dollar? Yeah, you need 4 quarters to have a dollar. A quarter is 1/4 of a dollar, 0.25. 0.25 is the same as 1/4. Alright, so 0.25 is 1/4. This blue part is 1/4 of the circle, 0.25. But if we double that, that's 1/2. What is the decimal for 1/2? Do you remember? 0.5. That's right. 0.5 is 1/2. Hey, it's raining quarters. Quarters are falling from the sky or from somewhere. That gives me an idea. Let's find out how much money you would have if you picked up some of these quarters. If you picked up just 1 quarter, how many cents would you have? 25 cents. Yep, 25 cents. Since we're dealing with money, we have this dollar sign, and 25 cents is written as 0.25, which remember is the same as 1/4 because 25 cents is 1/4 of a dollar. If you picked up a second quarter, you would have 50 cents. Awesome job! 50 cents. With 50 cents, we have the dollar sign, of course, and 50 cents is written as 0.50, which is the same as 1/2. 50 cents is half of a dollar. Okay, if you picked up 3 quarters, how many cents would you have? 3 quarters. 75 cents. Yeah, you would have 75 cents. When you write 75 cents, you include the dollar sign in the front and write 0.75, which is the same as 3/4, because 75 cents is 3/4 of a dollar. Finally, what if you picked up 4 quarters? How much money would you have? $1. A full dollar. $1 can be written like this, or like this, with a decimal point and 2 zeros, showing there are no extra cents. Both of these are ways to write $1. We've learned a lot about decimals in this video. Decimals are awesome. They're able to show us numbers that aren't whole numbers. Like here, we don't have a whole number of oranges. We have 1½ oranges. What is 1½ in decimals? 1.5. Exactly. We have 1.5 oranges. We learned that 0.1 is 1/10. Here is 0.1, 0.2, 0.3, 0.4, 0.5, which is the same as 1/2, 0.6, 0.7, 0.8, 0.9, and then 1! 1 complete circle. And finally, we learned that 1/4 is 0.25. Using decimals, how many pizzas do we have here? 2.25. 2.25. We have 2 whole pizzas and then an extra 1/4 of a pizza. But 3/4 of this pizza is missing. Do you remember what the decimal for 3/4 is? 0.75. That's right, 0.75. Fantastic job learning about decimals. Whoa! Since we're doing such cool things with numbers, I think it would be awesome to teach you a math trick, okay? A math trick. No, it has nothing to do with yo-yos, although you can learn a lot of tricks with a yo-yo. So what is this number trick? It's something cool called rounding numbers. Rounding numbers. Let's say Frankie loves playing tennis. He loves playing tennis so much, he has a huge collection of tennis balls. In fact, Frankie owns 39 tennis balls. His friends know he collects tennis balls, so one of his friends asks him, "About how many tennis balls do you have?" His friend isn't asking for the exact amount. His friend is asking about how many tennis balls do you have? His friend could have also asked this way, roughly how many tennis balls do you have? Frankie knows that 39 is just one less than 40, as you can see from this number line. So he answers, I have about 40 tennis balls. That's rounding. Rounding makes a number more simple when knowing the exact number isn't important. That's pretty awesome. Rounding makes a number more simple when knowing the exact number isn't important. In our example, Frankie rounded the number 39 up to the number 40. His friend didn't want to know the exact number of tennis balls. His friend asked for an estimate. Frankie has about 40 tennis balls. Rounding is especially common with bigger numbers. For example, did you know about 6 million people visit the famous Colosseum in Rome each year? Do exactly 6 million people visit the Colosseum each year? No. That's why we said about 6 million. The exact number was rounded so that the number we shared would be simple and easy to remember. That's what rounding does. Rounding makes a number more simple when knowing the exact number isn't important. It's used when we say words like about or roughly. We might say, there are about this many, or there are roughly this many. Okay, now that we know what rounding is and what it does, we need to learn how to round numbers. Let's pick a random number, 46. Before we do any rounding, we need to review our place values. Do you remember place values? It's important to know our place values so we can know exactly how to round the number. What digit is in the ones spot? Yes, the number 6. This first spot is always the ones spot. What digit is in the tens spot? The number 4. The second spot is always the tens spot. Great job! Now that we know the place values, let's round 46 to the nearest 10. You will always have two options, to round up or to round down. In this example, we will either round up to 50 or we'll round down to 40. But which one do we need to do? To find out, we need to look at the digit before the spot we are rounding to. The digit before the 4 is 6. If you are rounding to the nearest 10, you always look at the 1 spot. Okay, here is where we do the trick. If the spot before is 5 or more, round up. Let's say that again. If the spot before is 5 or more, round up. Alright, so the digit in the 1 spot is the number 6. Are we going to round up or down? Yes, up. So this number will go up to 50. That is the nearest 10. We did it. We rounded a number. 46 gets rounded up to 50. You did an awesome job. Let's do another one. Okay, how about the number 23? What digit is in the 1 spot? Yes, the number 3. This first spot is always the 1 spot. What digit is in the 10 spot? Yes, the number 2. The second spot is always the 10 spot. Now that we know the place values, let's round 23 to the nearest 10. Remember, you will always have two options, to round up or to round down. In this example, we will either round up to 30 or we'll round down to 20. Next, we need to look at the digit before the spot we are rounding to. The digit before the 2 is 3. If you are rounding to the nearest 10, you always look at the 1 spot. Okay, here is where we do the trick. If the spot before is 5 or more, round up. That's fun to say. Let's say it one more time. If the spot before is 5 or more, round up. Alright, so the digit in the 1 spot is the number 3. Are we going to round up or down? Yes, down. So this number will go down to 20. That is the nearest 10. That's how you round numbers. 23 gets rounded down to 20. Great job. Let's use the trick on an even bigger number because it always works, no matter how big the number is. Okay, how about the number 544? What digit is in the tens spot? Yes, the number 4. Remember, the second spot is always the 10 spot. What digit is in the hundreds spot? Yes, the number 5. The third spot is always the hundreds spot. Now that we know the place values, let's round 544 to the nearest 100. You will always have two options, to round up or to round down. In this example, we will either round up to 600 or we'll round down to 500. But which one do we need to do? Well, we need to look at the digit before the spot we are rounding to. The digit before the 5 is 4. If you are rounding to the nearest 100, you always look at the 10 spot. Are you ready for the trick? You know it now. If the spot before is 5 or more, round up. That's fun to say. Let's say it again together. If the spot before is 5 or more, round up. Cool. Okay, so the digit in the 10 spot is the number 4. Are we going to round up or down? Yes, down. So this number will go down to 500. That is the nearest 100, and that's how you round numbers. 544 gets rounded down to 500. Now you know the trick to round any number. If the spot before is 5 or more, round up. One more time. If the spot before is 5 or more, round up. Great job. You did awesome. Wow, rounding. That was really cool. Mr. Whiskers, are you still awake? It's a long video. You know what, Mr. Whiskers and kids, I think it's time to learn about time. I think it's time to learn about time. Let's learn about units of time next. Units of time. There are 3 main units of time in a day: seconds, minutes, and hours. A second is the smallest unit of time. It's so tiny. A minute is a lot bigger than a second. And then an hour is even bigger. An hour is the biggest unit of time in a day. We're going to look at each of these individually, okay? It is going to be a great time. Get it? It's funny, right? First, we're going to learn about seconds. A second is the smallest unit of time. It's extremely short. Now, a fair warning to you, you're about to see some very cute animals that are going to help us understand just how long a second is. Hey, what did we say? We warned you. Okay. The time that it takes this cute little dog to jump is a second. It's just like a moment. Boom. The dog jumps, woo, in the air for a second, down. And you see how this dog, he's jumping over that pole. Really cool. Great dog. It takes just a second to jump. That's a second. That's the sound. That's a second. Okay, another cute animal. This is a cat, and this cat is blinking. The time it takes to blink is a second. Not just for cats, for humans. Why don't you give it a try? Go ahead and blink. Yeah, that's a second. Can you blink again? That's another second. Can you blink again? That's a second. It's so short. It's such a short amount of time. Could you blink again? Okay, that'll be the last time. Okay, it's a second. It's a second to blink. Oh, who doesn't love a good seal? Here's a seal in the water saying hi by waving. That wave takes just a second. Did you know when we say hi, that takes a second too? Why don't we give that a try? Say the word hi. 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 That's a second. Hi. That's a second. Hi. Now, I don't want you to annoy people around you, but I want you to understand it just takes a second to say hi or to wave. Waving usually takes just a second. On a clock, seconds are shown with the thinnest line. It's also the line that moves the fastest because seconds are the shortest period of time. Now, you might not realize this, but every unit of time has an abbreviation. An abbreviation is a short form of a word, and seconds actually have two abbreviations. The abbreviations of seconds are sec or just the letter S. Here's an example. You could say 1 second. Or if you wanted to write it with an abbreviation, you could write 1 sec or just 1 S. Here's another example. 5 seconds could be written 5 sec or 5 S. Now you don't always have to do that. You don't always have to use an abbreviation. But if you want to abbreviate and make seconds shorter, you can just write 5 sec or 5 S. The final example, 10 seconds can be written 10 sec or 10 S. Sec or S are abbreviations of the word seconds. Seconds are the shortest unit of time. Next, we're going to talk about minutes. A minute is the next biggest unit of time after seconds. Now, how much bigger is a minute than a second? Well, believe it or not, a minute is 60 seconds. 60 seconds! 60 is a lot. Now, you might be wondering, how much is 60? I'd love to see that. Well, look at this. It's a lot! It's a lot! 60 is a lot. A minute is 60 seconds. Here's an example of something that takes about a minute. A little girl blowing bubbles takes about a minute. About 60 seconds. For a while, she'll blow these bubbles and then she'll be done. She might spend a couple minutes or she might just spend a minute. It's not too long, but it's not too short. It's a minute. This little boy's tired. Maybe he played for a long time and he just wants to sit down for a minute. This is something that might take a minute, sitting down and just taking a break. It wouldn't be enough of a break to just take a second break, but a minute can help him rest. A minute is 60 seconds. It's enough time to take a break, to breathe for a while, and then to go back to playing. Here's our final example of a minute. A little girl who's cuddling with her teddy bear. Maybe she named him Mr. Perkins, and maybe she'll give him hugs every once in a while, but now she's taking her time to cuddle him for 60 seconds, a minute. Maybe she'll spend about a minute. A second would just be too short to hug Mr. Perkins, but cuddling for a minute, she would take a minute to do that. On a clock, minutes are shown with the longest line, so when you look at a clock, the longest line, called a hand on a clock, that longest hand measures the minutes. Now remember, every unit of time has an abbreviation, and remember, an abbreviation is just a short form of a word. The abbreviation of minutes is min, M-I-N, min. Here's an example. 1 minute would be abbreviated 1 min. Look at this one. 5 minutes would be abbreviated 5 min. 10 minutes would be abbreviated 10 min. A minute is the next biggest unit of time after seconds. The last unit of time we're looking at today are hours. Hours are the largest units of time in the day. In fact, in a day, there's only 24 of them. Not many at all. Okay, so how long is an hour exactly? Well, an hour is 60 minutes. And do you remember how big the number 60 is, right? Ooh. Ah! Lots of minutes. 60 minutes. An hour is 60 minutes. Remember, a minute is 60 seconds. So it's a lot of time. Here's an example of an hour. This girl playing out in the snow. This girl would want to play out in the snow for like an hour, right? 60 minutes. 1 minute wouldn't be enough playing out in the snow. And 1 second, well, 1 second is like, hi, and that's a second, remember? So an hour is 60 minutes. It's a good long time to play out in the snow. And that's how long this little girl might be playing outside in the snow. Ah, fun! Playing out in the water, that's awesome! This is so much fun! This little boy is probably going to want to play in the water for about an hour, right? 1 minute wouldn't be long to play in the water at all. Remember, 1 minute is only 60 seconds. And 1 second, remember, hi, that's a second. So an hour is a good long time to play out in the water, to have a lot of fun, and to get some really great exercise. Here's our final example of an hour. This little girl is taking a nap. A nap oftentimes takes an hour. 1 minute wouldn't be long enough for a really good nap. And 1 second, well, you already know how long a second is. A second wouldn't do it all either. An hour is a good long time. On a clock, hours are shown with the thick, short line. And that's the line on the clock that moves the slowest because hours are so long. Now, as you've remembered before, every unit of time has an abbreviation, and an abbreviation is a short form of a word, okay? These kids already know this, okay? And why is this penguin moving so... The abbreviations of an hour are HR or just H. Here's an example. 1 hour could be written 1 HR or 1 H. Now 5 hours could be abbreviated 5 HR or 5H. And 24 hours, which is how long a day is, could be abbreviated 24 HR or 24 H. Great job learning about units of time. Oh my goodness, that was fun. That was fun. Oh, look at this dog. I think it might be time for a nap, little dog. Might be time for a nap. Well, I think we're ready for the next lesson. Next, we're going to learn how to tell time using analog clocks. Analog clocks. Clocks are amazing, wonderful inventions. Humans have used clocks for a really long time. In the ancient world, a common type of clock was the sundial. That's right, the sundial. Sundials are very accurate, but are not used often today. Have you ever asked what time it is and someone checks their sundial? Yeah, that isn't real common. Today, most clocks are digital clocks. Digital clocks are really simple to use. They simply show the digits for the hour and minutes. So here we have a digital clock. Here on the left, we see the hour. It is 7. On the right, we see the minutes, 10. So what time is it according to this clock? Yeah, it is 7:10. 10 minutes past 7 o'clock. What about this clock? Here is another digital clock. What time is it according to this clock? Yes, it is 10 o'clock. On the left, we see the hour, which is 10, and on the right, we see the minutes, which are just zeros, so it is exactly 10 o'clock. Now, digital clocks are not the only way we can see what time it is. Have you ever seen a clock like this before? Yeah, this is called an analog clock. It is a different way to display time. In this video, we are going to learn how to read analog clocks, which will be super awesome because there are analog clocks all around us that want to be read. They want to show us the time. So, to start, we are going to learn some fun things about the analog clock. The front is called the face of the clock, or the dial. Just like you have a face, an analog clock has a face. That's right. The face includes the numbers, the parts that spin, and all the markings on the clock. The face, sometimes called the dial, has two main parts that point to the numbers and spin around. They are called hands. Isn't that interesting? The shorter hand is the hour hand. It shows us what hour it is. The hour hand is short. The longer hand is the minute hand. It points to the minutes. It's silly, even though an hour is longer than a minute, the hour hand is shorter. The hour hand is the short hand, and the minute hand is the long hand. So just like you, analog clocks have a face, and usually have two hands. The short hand points to the hour. The long hand points to the minutes. Let's go back to our analog clock and see if we can figure out what time it is showing. Just like we do with the digital clock, let's look at the hour hand, the short hand first. What number is it pointing at? Yes, at the number 3. Great. So it is the third hour. It is 3 something. Now we just have to read the minutes. The minute hand is the long hand. But how do we read the minutes? It only goes up to 12, and those big numbers are what we use for the hours. What do we do? Mr. Whiskers, we're recording. What? You know how to read the minutes on an analog clock? I didn't even know you knew how to tell time. You're a cat. You have a trick? Well, we should hear the trick. It's important for us to learn how to do this. Okay, an analog trick with Mr. Whiskers. Okay, that's a little crazy, but that's okay. All right, so what's the trick? Oh, okay, so we need to count by 5s to find out the minutes. That's a wonderful trick. That's amazing. You see, all of those little lines in between the numbers on the face of the clock represent 1 minute. To find out the minutes, we just have to count by 5s around the clock, starting at the 12. The 12 is like the starting line. When the minute hand is at the 12, that means 0 minutes. Then the 1 is 5, 2 is 10, then 15, 20, 25, 30, 35, 40, 45, 50, 55, and then back to 0. All we have to do is count by 5s. Okay, so we're ready to figure out what time this is. Okay, so we already know what the hour is. The hour is 3. Yes. Okay, so we write 3. Now we have to figure out the minutes, and the minute hand is pointing at the 12, which means what? How many minutes? 0. Yeah, and with minutes, we always write 2 digits, so we'll write 2 zeros. What is this time? Yeah, 3 o'clock. Great job! Okay, let's try this one. What time does this clock say? Where's the hour hand? Yeah, on the 5. And where's the minute hand? Yep, at the 12. So you know there are zeros at the end of that. What time is it? Yes, it's 5 o'clock. Great job. All right, let's try this one. Okay, both hands are pointing at which number? Yeah, 12. What time is this? Yes, 12 o'clock. Great job. Notice if the minute hand is pointing at the 12, you always say o'clock. So this is 12 o'clock, just like before we had 3 o'clock and 5 o'clock. This is 12 o'clock. Terrific. Now we are going to change things up. Just remember our trick, count by fives, okay? Let's figure out what time this clock is showing us. First, let's look at the hour hand. Wait, it isn't directly pointing at a number, it is between the 2 and the 3. No worries, when the hour hand is between two numbers, the hour is the earlier number. So the hour is 2. Where is the minute hand pointing? That's right, at the number 6. We are going to use Mr. Whisker's trick and count by fives. We start at the 12, which is 0. Then we count 5, 10, 15, 20, 25, 30. So how many minutes is this showing? 30. That's right. So what time is the clock showing? 2:30. You got it. This one looks like fun. What time is it according to this clock? First, let's look at the hour hand. The hour hand is between numbers again. It is between which numbers? Yes, 8 and 9. Remember, when the hour hand is between two numbers, the hour is the earlier number. So the hour is 8. Where is the minute hand pointing? That's right. At the number 3, we are going to use Mr. Whisker's trick and count by fives. We start at the 12, which is 0. Then we count 5, 10, 15. So how many minutes is this showing? 15, yeah! So what time is the clock showing? 8:15, you got it! How about this one? What time is it according to this clock? First, let's look at the hour hand. The hour hand is between numbers again. It is between which numbers? Yes, 11 and 12. Remember, when the hour hand is between two numbers, the hour is the earlier number. So the hour is what? 11! You are right! Okay, so where is the minute hand pointing? Yep, at the number 9. We are going to use Mr. Whisker's trick and count by fives. We start with 12, which is 0, then we count 5, 10, 15, 20, 25, 30, 35, 40, 45. So how many minutes is this showing? 45, you got it. So what time is this clock showing? 11:45. Yes, great job. We looked at examples of when the hour hand isn't pointing directly at a number on the face of a clock. You know, sometimes the minute hand isn't pointing directly at a number. Look at this example. The hour hand is between which two numbers? Yes, 7 and 8. Which number is the hour? Yep, 7. The hour is always the earlier number on the clock when it is between two numbers. Now the minute hand is near the 8, but notice it went past the 8 by 2. To figure out the minutes, we will count by fives just like before, and then add 2 at the end. The 12 is 0, 5, 10, 15, 20, 25, 30, 35, 40. Then you just add 40 plus 2. You gotta add 2. What is 40 plus 2? Yeah, 42. So the time is 7:42. Wonderful job, that's great. Let's look at one last analog clock. Just looking at this clock, what is the hour? Yes, 12. Because 12 is the earlier hour on the clock. How about the minutes? Use the count by fives trick and notice the minute hand is 1 minute after the 4. You'll need to add 1 minute. All right, 21. So the time is 12:21. Let's check the minutes to be sure. 5, 10, 15, 20, then add 1, which is 21. You have done a great job. Before we conclude this video, we want to share 2 more things. What's with the swans? We are sharing 2 things about analog clocks. We aren't sharing 2 swans. Okay, so first, analog clocks sometimes use Roman numerals instead of regular numbers. Fancy clocks and clock towers usually use Roman numerals. If you need help with Roman numerals, we do have a video about that. The second thing is that you may see a thin hand, sometimes a different color than the hour and minute hands, that shows the seconds. It isn't always there, and it doesn't help you tell the time. It just shows how fast time is moving. The second hand moves really fast. To tell time, we use the 2 main hands, the hour hand and the minute hand. We learned that the front of an analog clock is called the face, or the dial. The pointers on the face of the clock are called hands. The short hand shows us the hour. If the hour hand is between 2 numbers, the hour is the earlier hour on the clock. The long hand shows us the minutes. To find the minutes, we count by 5s along the face of the clock until we reach where the minute hand is pointing. Sometimes we need to add a few minutes because the minute hand isn't always pointing directly at a number. It can take a lot of practice, but we hope this video helped you learn how to read analog clocks. Now you can read the time, no matter what type of clock it is, unless if it is a sundial. I mean, really? Really? All right, terrific job. And you know, we've got to keep this up. Let's keep the fun rolling and spinning because we're learning about US coins next. The US coins. This is going to be super cool. There are 6 types of US coins. We're going to look at each of the types individually so that no matter what coin somebody shows you, you'll know what kind of coin that is and how much it's worth. We're going to look at the penny, the nickel, the dime, the quarter, the half dollar, and even the dollar coins. All right, let's fly into our lesson. The first coin is the penny. So what is a penny? Well, the penny is a copper coin with Abraham Lincoln's face on it. Traditionally, pennies feature the Lincoln Memorial on the back. Remember, the Lincoln Memorial is a memorial in honor of Abraham Lincoln. In 2010, they changed the penny to feature the Union Shield on the back instead of the Lincoln Memorial. So if a penny has the Union Shield on the back, you know it's a newer penny. The penny is worth less than all the other coins. It is worth 1 cent, which is easy to remember, especially if you're looking at the penny, because on the back of the penny, whether it's an old penny with the Lincoln Memorial or a new penny with the Union Shield, it actually says 1 cent on the back of the coin. A penny is worth 1 cent. This is pretty weird. Did you know some people don't like the penny very much and they think we should get rid of the penny? In fact, it costs more to make a penny than it's even worth. So some people say, hey, we're losing money with making these pennies. Maybe we should get rid of the penny. As of today, it costs 1.67 cents to make a penny. That's actually less than it used to be. It used to cost 2 cents or 2 pennies just to make 1 penny. Even though some people want to get rid of the penny looks like it's here to stay. Ah, the penny. What a wonderful coin. It's got Abraham Lincoln on the front. Older pennies have the Lincoln Memorial, and newer pennies have the Union Shield on the back. They're worth 1 cent, so they're not worth much, but who hasn't gotten excited finding a nice new shiny penny? Cool! The second coin is the nickel. The nickel is a coin made of both copper and nickel that has Thomas Jefferson on it. Like the penny, the nickel has gone through a change in recent years. It doesn't look the way it has always looked. Traditionally, nickels feature the side of Thomas Jefferson's face. But in 2006, the nickel was changed to show the front of Thomas Jefferson's face instead of just the side. Old nickel, new nickel. Old nickel, new nickel. Old nickel, new nickel. Okay, you get the idea. Unlike the front of the nickel, the back of the nickel has stayed the same through the years. It features Monticello, which was Thomas Jefferson's house. A nickel is worth 5 cents, which is the same as 5 pennies. Because remember, a penny is worth 1 cent. So a nickel, being worth 5 cents, is worth the same as 5 pennies. The nickel, it's a coin that's the color silver, it's got a house on the back, which is Monticello, and depending on how old the nickel is, it either just shows the side of Thomas Jefferson's face or the front of Thomas Jefferson's face, and it's worth 5 cents. Awesome! Well, the third coin is the dime. The dime is a silver-colored coin made of both copper and nickel that has President Franklin D. Roosevelt on it. This is pretty interesting. The dime is the smallest size coin, but don't let the size trick you. It's worth more than the nickel and the penny combined. A dime, how much is it worth? Well, a dime is worth 10 cents, which is the same as 10 pennies. Wow, what's easier to carry around? A little dime that's worth 10 cents or 10 pennies? Oh my goodness. The dime, a really small silver-colored coin with President Franklin D. Roosevelt on the front and on the back, a torch. It's the same as 10 pennies, but it's a lot easier to carry around. At least, I would think, right? The dime. Pretty cool. Alright, the fourth coin is the quarter. Alright, well, what is a quarter like? Well, the quarter is a silver-colored coin made of both copper and nickel that has George Washington on it. And yeah, it's a much bigger-sized coin than the dime, that's for sure. The back of a regular quarter has a bald eagle on it. And we say a regular quarter because there are so many quarters that aren't just regular quarters. It's kind of an interesting coin that way. Quarters are cool coins because there are 3 special quarter collections. The state quarters that have states on the back, the territory quarters that have territories on the back, and America the Beautiful quarters that have different scenes from the United States of America on the back. Here's a fun hint. Even if the back looks different, if it is a silver-colored coin with George Washington on it, it is a quarter. You might be wondering, how much is a quarter worth? Well, a quarter is worth 25 cents, which is the same as 25 pennies, because remember, pennies are worth 1 cent. So imagine what's easier, carrying around 1 quarter or 25 pennies, right? Oh my goodness, quarters are awesome. The quarter is a large silver-colored coin with George Washington on the front and a bald eagle on the back. But be careful, there are lots of special edition quarters like state quarters, territory quarters, and America the Beautiful quarters. Just follow our hints and look at the front of the coin to find out if it is a quarter. And remember, the quarter is worth 25 cents, which is the same as 25 pennies. Alright, are you ready for the fifth one? I can't hear you, come on. Okay, alright. The fifth coin is the $half. Well, what's the $half like? The $half is a silver-colored coin made of both copper and nickel that has President John F. Kennedy on it. The back of the $half features the presidential seal surrounded by 50 stars. What do you think the 50 stars represent? Do you have an idea? Yeah, the 50 states of the United States of America. And remember, there's a bald eagle on the back of a quarter too. But on the $half, that bald eagle, which is part of the presidential seal, is surrounded by stars. So if it's surrounded by stars, you know it's a $half. Plus, the back of the coin says $half, so that makes it easy too. You can look high and low for $half, but they're pretty rare. In fact, you might not see one for a really long time. One thing you can do is you could go to the bank and take 2 quarters with you. When you take those 2 quarters, you can ask if they have any $half, and you can trade 2 quarters for $1/2. They still make $half, but as we said, they're more rare than the quarters, the dimes, the nickels, and the pennies. You might have figured this out already, but it is called a $half because you only need 2 to have a dollar. It only takes 2. If you have 2 $half, then you have 1 whole dollar. Well, if that's true, how much is a $half worth? Well, the $half is worth 50 cents. That's the same as 50 pennies. Whoa! This coin is worth a lot. The $half, pretty awesome coin. It's silver colored and has President John F. Kennedy on the front. On the back is the presidential seal surrounded by stars, and it's worth 50 cents. Oh my goodness, you only need 2 of these coins to have a whole dollar, but I wouldn't trade 2 of them for $1 because they are rare, and when you find a $half, oh my goodness, that's such a treasure. It's so cool because they are rare and they are limited, but oh my goodness, I just love the $half. The $half are awesome. The final coins are the dollar coins. There are 2 main dollar coins. There's the Sacagawea dollar, and there are the presidential dollars. We're going to look at both of those right now. The Sacagawea dollar, also known as the Golden Dollar, honors the extraordinary Native American woman who helped Lewis and Clark in their expedition out west. The back of the Sacagawea dollar features a bald eagle in flight. What's with these bald eagle coins? It's just an American bird, right? The bald eagle. And so this is another bald eagle coin, but it's golden color. That's why the coin is called the Golden Dollar. So if you see a golden coin with an eagle on the back, it's a Sacagawea dollar. And finally, the presidential dollars, which celebrate the first 40 presidents of the United States, all the way up to Ronald Reagan. From George Washington to Ronald Reagan. Here's one with Gerald Ford on it. Really cool collectible coins that feature the first 40 presidents. Well, what does the back look like? Well, the back of the presidential dollars feature the Statue of Liberty. Really cool. And they all say $1 on the back, which makes sense because they are dollar coins. The dollar coins. There's two types, right? The Sacagawea dollar, also known as the golden dollar, and the presidential dollars. These are wonderful coins that look really cool. People actually didn't like even buying stuff with them, they just wanted to collect them. But these dollar coins are really neat. You might see one and wonder, what kind of coin is this? And then you'll remember this video and say, hey, this is a dollar coin. Wow, that was cool. The US coins. Okay, well, we still have a lot of fun ahead in this math adventure. Remember, this is the all-in-one elementary math video, you know? So, of course, we need to learn about Roman numerals. Roman numerals. Let's learn about that now. We're going to be learning Roman numerals, which is a different way to write numbers, and it was used a long time ago in ancient Rome, and it's been used since then, and you can think of it almost as a secret code way of writing the numbers. It's pretty simple to learn, and we're going to go through that. The first Roman numeral we're going to learn is the Roman numeral I, and I is 1. I equals 1. So if you see an I with a Roman numeral, it's 1. The letter V is the Roman numeral that means 5. And the letter X is the Roman numeral that means 10. So when you think 1, it's an I. If you think 5, it's a V. And if you think 10, it's an X. So that's it, just those three. I, it almost looks like a 1. That's how you can remember that I is a 1. I is the Roman numeral for 1. A V is in the number 5 when you spell it out. The number 5, you see that right there? It has a V in it. So when you think of V, you know, oh, you know what? There's a V in the spelled out number 5. So V has to be 5. Now, 10 is X, and we can't think of anything that could remind us of that. So there is no memorization thing. Just when you see the X, it's 10, and that's just what we're going to have to do. Okay, one last time here. I just want to make sure you get it. There's only 3. I is the Roman numeral for 1. V is the Roman numeral for 5. And X is the Roman numeral for 10. And you gotta understand that so that we could start playing kind of a game of putting them together and making numbers other than just 1, 5, and 10. So let's get started. So let's practice putting these Roman numerals together. What number do you think this is? You see 2 I's, and I is 1, so the answer is 2. 2 I's is the number 2. What about this one? What number do you think this is? There are 3 I's. Yeah, it's the number 3. Let's try this one. What number do you think this is? We see 2 X's, and X equals 10, so 10 plus 10 equals 20. Great job! This is the number 20. Whoa, this one is so cool. Okay. An X and a V. What number do you think this is? The X is a 10. The V is what number? 5. Awesome. So what is 10 plus 5? 15. Whoa! Thanks so much for helping out. Now that we've looked at how to put some of these together, I want to tell you about 2 special numerals that are a little bit different, and so you're going to have to just remember these on their own. The first is the number 4, and the number 4 is represented with an I and a V, and the I is before the V because 4 is 1 less then 5, which is V. So remember, with 4, it's IV. With 9, it's similar, except with the X. 9 is IX, X is 10, and I is just before it, so 9 is IX. Well done. You did a tremendous job learning some of the basic Roman numerals. Very cool. I have a new topic for you to take a swing at, okay? And I've got to tell you, I feel super excited because we are about to learn about lines, line segments, and rays. And then we can all clap, in celebration. I mean, look how happy this guy is, and he knows all about lines, line segments, and rays. Right, Bill? Right? Okay, he's doing his own thing. In math, a line looks like this. You have a line with 2 arrows, one on each end. These arrows show that the line keeps going on forever in both directions. A line has 2 arrows. Now, a line segment is so different. It has these 2 dots, one on each end. These dots are endpoints. It doesn't keep going and going. It starts at one point and then ends at another. This is a line segment. So here's a line. We know it's a line because it has these 2 arrows. Pretty cool. The arrows show the line keeps going and going in both directions, right? And what's this called? Do you remember? Yeah, a line segment. It has these 2 dots. They are endpoints. A line segment doesn't go on and on. It has these 2 endpoints. There's a beginning and an end with a line segment, isn't there? Now, what about a ray? What does a ray look like? Well, a ray is kind of a combo, a combination of the 2. You can see it right here. A ray has an arrow on one end, making it like a line on that side, but a ray has a dot on the other side, an endpoint, like a line segment. A ray has an endpoint and an arrow. A ray is a combo, right? It has both. All right, so a line has 2 arrows. It goes on and on in 2 different directions. A line segment has 2 endpoints. It doesn't go on and on like a line does. It stops at the endpoints. It's pretty cool. And a ray has an arrow on one side and an endpoint at the other. That means a ray goes on in one direction, and then the other side just has that endpoint. A ray has both an arrow and an endpoint. Hey, I think it's time. It's time to unlock and discover a super trick. Something used by the true masters and legends of math. A trick you can use to discover if you are looking at a line segment, or a ray. Even this guy uses the trick. In fact, I think he may be writing me a letter right now. Dear Homeschool Pop, thanks for helping me with my math and for buying me these candles for my birthday. Okay, here's the trick. Just count the arrows and endpoints to see if you are looking at a line segment, or a ray. You might have picked up on that already. See, we already know that a line has 2 arrows, a line segment has 2 endpoints, and a ray has 1 arrow and 1 endpoint. So we count the arrows and endpoints to discover what we're looking at. That's pretty simple. Just count the arrows and endpoints to see if you are looking at a line segment, or a ray. That's the trick. You know, you've been doing an amazing job learning. I think you're ready for a very special game of Tell Homeschool Pop What You See. Whatever you see on the screen, just tell me. That's it. That's the game, okay? Let's start with this one. What do you see? Yeah, a flamingo. Yes, this is a flamingo. Great. All right, I know, you were probably expecting something different, something related to this video. The thing about this game is you don't know what you will see next. Let's keep going, okay? All right, what do you see here? What is this? Yeah, a line segment. Fantastic! How do we know it's a line segment? It has 2 endpoints. 2 endpoints. This is definitely a line segment. Great job. Okay, what do you see here? What is this? Array. Awesome. Array. How do we know it's array? Yeah, it has an endpoint and an arrow. Very cool. Here is our last one. What do you see here? What is this? You've got it. A line. Sweet. How do we know it's a line? It has 2 arrows. That's right. It has 2 arrows. This is a line. Wow. I must say, I'm impressed. You did such a great job. You know what? I'm going to say it. I'm going to say it. You know all about lines, line segments, and rays. You learned so much. You learned this is a line. It has 2 arrows, right? A line segment doesn't have arrows, but has endpoints instead. And a ray has 1 arrow and 1 endpoint. That's it. Wow, this is a cute bunny. Speaking of cute, I better go feed Mr. Whiskers. Yeah, I better. Mr. Whiskers! Mr. Whiskers! Okay, things got silly there. All right, now we're going to learn all about shapes. Let's start with the 2D shapes. The 2D shapes. We are going to investigate them one by one. We're going to take you on a journey to discover the 2D shapes, the easy ones and maybe some of the ones that maybe you don't know yet. Some of the 2D shapes are super easy and you'll be like, I know all of these! But then some of the other shapes are a little more tricky and it's like, I don't know if I've learned this before. Wait, can we all agree that was a very weird sound and we should just probably never record that kind of sound again? Yeah, that was not good. All right, 2D shapes! Let's go back to that. Okay, so let's start here. The trusty circle. We love the circle, right? You gotta love circles. Circles are cool. This is what a circle looks like. Here it is, your basic circle. You know, this is what a circle looks like. It looks like a really big dot, doesn't it? Next, let's look at this shape. This shape is a triangle. A triangle. This is very interesting. Okay, here it is again, the triangle. The triangle. Now, triangles are easy to spot, not just because you can learn what this shape looks like this. You can actually count the sides of the shape to discover that the shape is a triangle. So let's count the sides together. 1, 2, 3. This shape has 3 sides. A triangle has 3 sides. Not all triangles look the exact same. Look at this triangle. We know that this is a triangle because of its sides. Let's count them together. 1, 2, 3. There are 3 sides. Every triangle has 3 sides. It just looks more squished than the other triangle, but it's still a triangle. Now here is something very interesting, very interesting. Let's say we took the triangle and we stretched it out. It's still a triangle, right? But if you did the same thing to the circle, if you stretched out that circle, it actually becomes a different shape. A shape called what? Yeah, an oval. An oval, when you stretch out a circle, it becomes an oval. And that's our third shape. Here it is again. An oval. An oval. An oval is a stretched out circle, basically, right? An oval. You've seen these around, right? Can you say that with us? Oval. Oval. Good. Let's look through these three shapes again just to make sure we really know them. What is this shape? Yeah, a triangle. What's this shape? Do you know? Yeah, it's an oval. What's this shape? Yeah, a circle. Okay, what is this shape? Yeah, it's an oval. What is this shape? Uh-huh. It's a triangle. What is this shape? Yeah, a circle. Now we're going to get help from our friend Clarence, who's going to show us the next four shapes. Okay, the next four shapes all have one thing in common. They have four sides. Four shapes that have four sides. So let's meet these shapes. The first one is this shape. This shape is a square. A square. A very common, very popular shape. The next shape is this shape. What is this shape? Do you already know? Yeah, a rectangle. A rectangle. The next shape is not as popular, and you might not be familiar with it. This shape is a trapezoid. Oh, that's a fun word to say. Can you say trapezoid? Wow, trapezoid. And the final shape is this one, which is a parallelogram. Wow, parallelogram. First, let's look closer at the square, okay? The square has four sides, of course, but all four of the sides are the same length. Okay, so it looks like a perfect box, doesn't it? A square has four sides that are all the same length. Next, we're going to take a closer look at the rectangle. Yeah, rectangles are pretty cool. They are usually drawn like stretched out squares, aren't they? It almost looks like a square that's been stretched out. But a rectangle is any shape that has four sides and has four corners that look like these. And they're usually drawn like this, so they can be drawn differently. They're usually drawn like a stretched out square. Next, we are going to take a closer look at the trapezoid. What a cool shape name, trapezoid. Two of the sides are parallel to one another, and the other two sides are not. That's what makes a trapezoid a trapezoid. You might be wondering, what does parallel mean? Well, let's show you. We'll show you with these lines. These lines are parallel to one another. Parallel lines are the same distance apart at every point. They never move closer or further away. Let's look at our trapezoid again. The top side and the bottom side, those are parallel to one another because at every point they're the same distance from each other, aren't they? But what makes a trapezoid so unique is look at these two sides. These two sides are not parallel to one another. They're actually moving apart as you move down the shape, don't they? Those sides are actually moving away from one another. They are not parallel to one another. That's what makes this shape a trapezoid. Okay, Clarence, we hope you're ready. The last four-sided shape that we're going to be looking closer at is the parallelogram. And as the name might suggest, it's named after the fact that the opposite sides of the parallelogram are always parallel to one another. That's what makes a parallelogram a parallelogram. A parallelogram can be drawn in many different ways, but this is the most popular way to draw a parallelogram. To draw it almost like a rectangle that is having the wind blow really fast towards it, so it's almost bending backwards. It's almost looking like a slanted rectangle. That is the way that a parallelogram is usually drawn. Okay, so what's this shape? Do you remember? Yeah, a square. And what about this shape? A rectangle. What about this shape? It's a parallelogram. And what about this shape? What's this? A trapezoid. Hey, Clarence, thanks for helping us with... Oh, are you brushing your teeth? Oh, okay, well, good for you. That's awesome. Thanks for helping. And wow, it's important to brush your teeth. This is great. I didn't know bears brush their teeth, but that's phenomenal. That's great. All right, we've got more shapes to cover here. We gotta go. Sorry, Clarence. We're gonna leave your bathroom now. We only have 3 more shapes to show you. The first is the pentagon. The pentagon has 5 sides. Next is the hexagon. The hexagon has how many sides? 6. 6 sides. A hexagon has 6 sides. And the final shape we're showing you today is the octagon. The octagon has 8 sides. 8 sides. You've seen these shapes before. Have you ever played soccer? Yeah, you see 2 of the shapes in a soccer ball. The white panels are hexagons. Each white panel is a hexagon. And you can see there are 6 sides for each white panel on a soccer ball. And each black panel is a pentagon. There are 5 sides for every black panel on a soccer ball. A soccer ball is covered in hexagons and pentagons. You've also seen octagons in real life. Have you ever noticed that a stop sign is an octagon? Yeah, a stop sign is an octagon. It's a shape that has 8 sides. Hey, a special thumbs up to you. You've done a great job. In fact, you've done so well. We're gonna quiz you. Yeah, it's quiz time. It's quiz time. I hope you're ready. It's quiz time. We're gonna find out how many of these shapes you can remember that you know. It's gonna be awesome. You're gonna do great. You've been paying attention. Okay, what is this shape? If you need to count the sides, go ahead. What is this shape? This shape is an octagon. Good job. Okay, here's the next one. What is this shape? What is this shape? Do you remember? A trapezoid. Yeah, what a fun name to say. Trapezoid. This is a trapezoid. 2 of the sides are parallel to one another, and the other 2 sides are not parallel to one another. Okay, let's try this shape. What is this shape? If you need to count up the sides, what shape is this? Great job. A pentagon. A pentagon has 5 sides. Great job. Okay, you're doing a great job. How about this shape? Okay, how about this shape? What shape is this? Yeah, a triangle. A triangle. We know it's a triangle because it has how many sides? 3. A triangle has 3 sides. Well done. Alright, let's give this shape a whirl. What shape is this? What shape is this? Looks pretty cool. But what shape is it? Do you remember? Uh-huh. A parallelogram. That one's fun to say too. Parallelogram. Can we say that together? A parallelogram. Oh, you can say it louder than that. Parallelogram. Oh, come on. One more time. One more time. Parallelogram. Great. A parallelogram. All right, here is the last shape that we're going to quiz you on. What is this shape? You can count up the sides. What kind of shape is this? Wow, impressive. Yeah, this is a hexagon. We know it's a hexagon because it has how many sides? 6 sides, yes, wow. Very impressive. That is so impressive. Well done. That's great. This is a hexagon because it has 6 sides. Very cool. Great job. Now that we've learned about the 2D shapes, we're going to move on to the 3D shapes. The 3D shapes. How cool does that sound? The 3D shapes. So as we're starting out, it's important to remember what makes a 3D shape a 3D shape. There's an old rhyme that says 3D shapes are fat, not flat. And you can see that with the sphere, which is a 3D shape we're about to learn, and the circle. The circle is flat, but the sphere is 3D. It's 3-dimensional, and all the shapes are like that. So let's learn all these 3D shapes. So the first 3D shape we're going to learn is the sphere, the one that we just mentioned. The sphere is the 3D version of the circle. It's perfectly round. There are spheres all around us. One of the spheres we see all the time are balls like this soccer ball. A soccer ball is a sphere. It's perfectly round. It's a 3D circle. It's a sphere. You know this sphere. Yes, it's the Earth. It's where we live. Our planet is a sphere. How cool is that? Our own planet is a sphere, perfectly round. It's a sphere. In this picture, we have 2 spheres. Can you spot them? Yeah, the 2 spheres are the 2 bowling balls. Perfect round spheres. Spheres are all around us. Here we have a group of 3 spheres, and you can count them right now. 1, 2, 3 spheres all together. The shape of a ball, a sphere, perfectly round. Well, there you have it, the sphere. What a cool 3D shape to start with. It's round, there are examples all around us, and it's just so cool. And you know what? The 3D shapes are going to get even better. Our second 3D shape is the cone. The cone is a really cool shape with a circle as the base or the bottom, and it all comes up to one point called a vertex. Here's an example of a cone I think we all love, the ice cream cone. If it doesn't have any ice cream inside and you flipped it upside down, you'd be able to see the circle base, and it all comes up to one point called the vertex. Here are 2 cones, a red cone and a blue cone, and you can see both cones have that circle base and it all comes up to a vertex. What wonderful cones! Have you seen these before? They're traffic cones. Here are many cones. I didn't count all of them, but there's a lot, and they're wonderful, wonderful cones. So that's our second 3D shape, the cone, a wonderful cone with a great circle base. It all comes up to one point called the vertex. How awesome is that? Our third 3D shape is the pyramid. I love the pyramid. The pyramid's great. It comes up to one point, just like the cone, except the base is a square, and the sides, instead of being smooth, they are triangles. Okay, like, these are awesome! These are so cool. The pyramids of Egypt, you see that they have the triangle sides, and the bottoms of these pyramids are square. They're awesome examples of the pyramid. This is a pretty cool pyramid. It's a decoration that you plug into the wall, but it's a great example of what a pyramid looks like. The bottom or the base is square, and there's the triangles on the sides. How cool is this? Here's another pyramid, and it's made of glass. There are so many decorations and things around, maybe even your house, that are shaped like a pyramid, because pyramids look so cool. People love putting them everywhere. And there you go. I mean, the pyramid, it's a good shape. You see a lot of them around. They've got the square bottom or base, and the triangles on the sides, and all goes up to a vertex. It's a classic shape. It's pretty awesome. Our fourth 3D shape is the cylinder. Now, a cylinder is easy to spot because it's got a circle on the top and a circle on the bottom, and it's smooth all around. Here we have a can of soup, and it's a cylinder. It has a circle on the top, a circle on the bottom, and it's smooth all around. All cans and most jars are cylinders. Here we have 3 cylinders. They're candles. And can I tell you a secret? Most candles are cylinders too, right? Oh my goodness, this is just too crazy and too awesome. Here are 2 more cylinders. Are you kidding me? Are you kidding me? Even batteries are cylinders? Cylinders are seriously everywhere. A circle on the top, a circle on the bottom, and smooth all around. I mean, really, the cylinder is everywhere. I mean, the circle on the top, circle on the bottom, smooth all around. Cylinder, like, what in the world? Do you have to be everywhere, okay? The next 3D shape is the cube. The cube is the 3D version of the square. It has 6 sides or faces that are all squares. Here we have 2 dice. Dice are in the shape of a cube. So these 2 dice are 2 cubes. They have 6 sides or faces that are all squares. Here we have many cubes. These are cubes that are made out of wood. Each of them have 6 sides or faces that are all squares. Here are 7 cubes of ice. Have you ever had a warm drink and you need to put ice in it? It's awesome because it has this great shape, the shape of a cube. 6 sides or faces, all squares. I mean, there you go. The cube, right? The 3D version of a square, and it's got squares all along the sides, right? There's 6 sides or faces, all squares, and I don't know. I think it's a pretty cool shape. Our final 3D shape is the rectangular prism. The rectangular prism is the 3D version of the rectangle. It has 6 sides or faces that are all rectangles. Okay, an awesome example of the rectangular prism are bricks. And here we have 4 bricks, which are 4 rectangular prisms, the 3D version of the rectangle. You may have seen this in your classroom or in your home. It's a Kleenex box, and the Kleenex box is a great example of the rectangular prism. It's got 6 sides or faces that are all rectangles. Okay, so the secret is most boxes are rectangular prisms. So here's another rectangular prism, and it's a box, and it's a shorter box, but it still has rectangles all around, and it's a rectangular prism. What else can we say? It's a cool shape. The rectangular prism is the 3D version of the rectangle. It has 6 sides or faces that are all rectangles, and it's just a neat shape to have around, I think. I mean, you know, it's cool. So let's review. Pyramid, cylinders, sphere, cylinder, cones, pyramid, rectangular prism, spheres. Let's do some more. On the top here we have cubes. We can tell that because it's a 3D square. It has 6 sides or faces. Each of them are squares. It's pretty cool. Do you remember what shape these bricks are? Yeah, a rectangular prism. They are rectangular prisms. They're the 3D versions of the rectangle. At the top we have a cone. A cone. It's got a circle base on the bottom, and it all comes up to one point called a vertex. Do you remember the shape here on the bottom? These are 3 cylinders. They have a circle on the top and a circle on the bottom, and it's smooth all around. You're doing such an awesome job. Seriously, it's so cool. So what's this top shape? Do you remember? Yeah, it's a pyramid. A pyramid has a square base. It comes up to one vertex or one point, and it has triangles as the sides. Alright, do you remember this last shape here on the bottom? Yes, it's the sphere, which is the 3D circle, and we started with it, and we're ending with it, and it's so awesome! Awesome job. What do you think, little dog? Just hanging out? I get that. I get that. That's cool with me. Speaking of cool, the next math topic is super cool, okay? Next, we're gonna learn about symmetry. Symmetry. Yeah. If you don't know what that is, that's okay. You are about to find out, like right now, alright? Look at this triangle. It's a yellow triangle with a red border. Sometimes warning signs on the road look like this. To show you how symmetry works, I'm going to place this line down the middle of this triangle. Okay. It's still one triangle, but now it has 2 sides. Do you notice anything about the 2 sides of this triangle? Both sides match each other perfectly, don't they? That's pretty neat. And that's actually what symmetry is. This line is called a line of symmetry. A line of symmetry. If you were to draw this line down the middle of this shape, both sides would match. Aw, look at this butterfly. Does this picture of a butterfly have symmetry? Yeah. If we place a line down the middle of this picture of a butterfly, you can see both sides match each other. Yes, this line is called, do you remember? A line of symmetry. Yeah, a line of symmetry. We know it's a line of symmetry because both sides match each other. Actually, butterflies are symmetrical in real life. The patterns on both of their wings are identical to each other. They match. Butterflies are symmetrical. Let's check out some of the letters and see which ones have symmetry. We can try the first letter, the letter A. Does the capital letter A have symmetry? Yeah, it does. The capital letter A has one vertical line of symmetry, right here. Now, how do we know that's a line of symmetry? Well, we look at both sides. Do both sides match? Yes, great job. Both sides match each other. And if both of those sides match, you know the capital letter A is symmetrical. It has symmetry. That's pretty cool. I like symmetry. Hey, next, how about we look at the capital letter Y? Does the capital letter Y have symmetry? What do you think? Yeah, it does. The capital letter Y has one vertical line of symmetry. You can see it right here. We know it's a line of symmetry because we look at both sides to see if they match. Do they match? You got it. Both sides match each other. Aw, best friends. I assume they match, they might be friends. When the two sides match, that tells us the capital letter Y is symmetrical. It has symmetry. Pause for a moment, even the music, okay? I need to share something with you. And no, it's not that my true dream and passion is to make cat-themed electronic dance music in honor of Mr. Whiskers, of course. It would be in honor of you, Mr. Whiskers. Let's be honest, it's actually a pretty good idea. I think people might like it. No, this is just something some people don't realize about symmetry, okay? Here it is. Lines of symmetry don't have to be vertical, meaning lines of symmetry don't have to go up and down. Lines of symmetry don't have to be vertical. Take the letter C, for example. Does the letter C have symmetry? Well, if we try a vertical line of symmetry, it would seem like the answer is no. These sides don't match. But wait, if we try a horizontal line of symmetry, do both sides match? Yeah, they sure do. So does the letter C have symmetry? Yes, it does. That means the letter C is symmetrical. Oh wow, here are more butterflies. They are symmetrical. They have symmetry. But I don't think they know that. They go about their whole lives, and I don't think they ever figure that out. Wow. Someone should tell them, right? I don't know. Okay, let's try the letter L. Does the capital letter L have symmetry? Oh, this is going to be fun. Let's check with a vertical line first. Then we can just look at both sides. Do they match? Yeah, they don't match. This is not a line of symmetry. Hey, that's okay. Let's check with a horizontal line, all right? Do both sides match? You're right, they don't. What? No symmetry. Oh. Okay, wait, what's Rover doing on the screen? And what's with the sad music? It's okay that the capital letter L doesn't have symmetry. It's fine. We don't have to be sad. Rover, I promise you, you don't have to be sad. Look, if something doesn't have symmetry, it's this special thing called asymmetrical. Asymmetrical, that's a long word. Asymmetrical. If a letter, picture, or shape has no symmetry, it's asymmetrical. Let's look back on the capital letter L. Remember, the capital letter L has no symmetry. We tried to see if it had a vertical line of symmetry, but these sides don't match. If the sides don't match, you have no symmetry there. Then we tried to see if it had a horizontal line of symmetry, but again, the sides did not match, so there is no horizontal line of symmetry either. The capital letter L has no symmetry. That means the capital letter L is asymmetrical. Asymmetrical means it does not have symmetry. There are other letters that are asymmetrical too. Look at the capital letter R. Let's try a vertical line of symmetry first. Do these sides match? You've got it, they don't match. Wait, how about a horizontal line of symmetry? Do these sides match? Yeah, they don't match either. The capital letter R is asymmetrical. Wait, how about a lowercase r? Can you tell just by looking at it? Is a lowercase r symmetrical or asymmetrical? A lowercase r is asymmetrical too. When you're looking for symmetry, you are looking to see if the sides will match. The lowercase letter r is asymmetrical because none of the sides match. If you try a vertical line of symmetry, these sides don't match, do they? And if you try a horizontal line of symmetry, these sides don't match either. Aha! A treasure map! Actually, this is just a regular map that looks really old. I tried to find footage of a treasure map that has our last letter, the letter X, on it. Okay. But, you know, they have to keep the treasure maps secret. Maybe that's why I can't find that, okay? But the letter X is the last letter we're going to look at. I'm so excited because you are quickly becoming a symmetry expert, okay? So let's look at the letter X together. Now, just by looking at it, do you think it's symmetrical? Is the letter X symmetrical? Yes, it is. We can try a vertical line of symmetry first. Do both sides match? Yeah, they match. But here's the cool thing. We can try a horizontal line of symmetry too. Do both sides match? They do. That means the letter X has 2 lines of symmetry. Wow, that's pretty neat. Be warned, pirates. Some pictures, letters, and shapes have more than 1 line of symmetry. Okay, let's tie all of this together. When you are looking for symmetry, look for sides that match. The line down the middle that shows symmetry is called a line of symmetry. A line of symmetry. If it has symmetry, it is symmetrical. If it doesn't, it is asymmetrical. And if it is symmetrical, it might have more than 1 line of symmetry. So keep that in mind. You did such a phenomenal job. Have fun looking for symmetry all around you, looking for sides that match. That's great. Well done. Whoa. A detective. I don't have any information about your cases, but what I can say is if you stick around, I can teach you about perimeter. That's actually the next lesson, okay? It's for the kids, but you can watch too. All right, let's learn about perimeter. Imagine I'm a race car driver, right? And don't make fun of my car, okay? This is a perfectly good car to do a race in, right? It's very fast. It's got the bells, it's got the whistles. It's a great race car, okay? Stop laughing at it. Okay. Now imagine this is the race car course that I'm driving on, right? It's going around an oval. It's going around a shape. If I was wondering, how far is it around the track? What's the distance around the shape? Then I would need to know the perimeter. The perimeter is the distance around a shape. Wait. What is the perimeter? The perimeter of a shape is the distance around a shape. And it's easy to find. You can find the perimeter of a shape by adding all of the sides. That will tell you what the distance around the shape is. Great, now let's practice finding the perimeter. Look at this triangle. What is the perimeter of this triangle? Okay, first we need to know how long all of the sides are, then we can figure out the perimeter. With this triangle, all 3 sides are the same length. So how long are they? Let's pretend we measured it, and each side is 10 centimeters. Now remember, to find the perimeter of a shape, we need to know the distance around the whole shape. So we just add the sides together. What's 10 plus 10 plus 10? That's 3 tens. What does that equal? Yeah, 30. Awesome. The perimeter of this triangle is 30 centimeters. Remember, cm is an abbreviation for centimeters. 30 centimeters is the perimeter of this triangle. Okay, let's try this one. What is the perimeter of this square? First, we need to know how long all the sides of the square are. Then we can figure out the perimeter of the square. Okay, so this is a square. It has 4 sides, and all 4 sides are the same size. Let's pretend we measured it, and each side is 1 yard. Remember, YD is an abbreviation for the distance of a yard. Each side is 1 yard. Remember, the perimeter is the distance around a shape, so we'll need to add all of these sides up. Okay, what's 1 plus 1 plus 1 plus 1? Yeah, 4. The perimeter of this square is 4 yards. The perimeter, remember, is the distance around a shape. If you were to go around this entire square, it would be 4 yards. Okay, this is the final one. What is the perimeter of this rectangle? Well, first we need to know how long all the sides of the rectangle are. Then we can figure out the perimeter. Remember, a rectangle has 4 sides, and 2 of the sides are shorter than the other 2 sides. With this rectangle, let's pretend we measured it at 1 meter on the short sides and 3 meters on the longer sides. Okay, remember, to get the perimeter, we have to add all of the sides together. So we're going to be adding 4 numbers together again. To make it easier, we're going to group the smaller numbers together and then put the larger numbers in our equation. What's 1 plus 1 plus 3 plus 3? Those are all the sides. What's 1 plus 1 plus 3 plus 3? Yeah, 8! That means the perimeter of this rectangle is 8 meters. Wow, we told you it was going to be fun. Oh, it's such a blast finding the perimeter. The perimeter is so much fun to find. It's like a game. Remember, you can find the perimeter of a shape by adding all of the sides. And the perimeter of a shape is the distance around a shape. Nice job learning about perimeter. Whoa! Did you watch that part, Detective? Oh, you're on the phone. Okay. Well, maybe you can watch this next lesson. You'll like it. It's all about area. That's what we're learning about next. Area. Area is something we can discover about shapes. The area of a shape refers to how much space is inside of it. Area is very different from perimeter. If you'll remember, perimeter is the space around a shape. Area is the space inside of a shape. Alright, so area is the space inside of a shape, and perimeter is the space around a shape. So they're very different, aren't they? And this video is all about area. We're going to learn how to find the space inside of a shape. This should be fun. Let's play a game called What's the Area? We want to find the area of this shape. What kind of shape is this? Yeah, a square. Remember, the area of a shape is the space inside of the shape. we are going to measure the area of the shape using square units. So the area of the shape is how much space is inside of it. So how many square units are inside of this square? Do you know? If you don't, just count them up. Yeah, 4. There are 4 square units in this square. 4 square units is the area of this square. Okay, that was cool, right? Let's try figuring out the area of this rectangle. Just like last time, we are going to measure the area of this rectangle using square units. Remember, the area of a shape is the space inside of the shape. So, how many square units are in this rectangle? Do you know? Yeah, there are 5 square units in this rectangle. Great job! That's the area of this rectangle. 5 square units. Awesome. Now we are going to look at an irregular shape. What is the area of this shape? Just like we did with the others, we are going to measure the area of this shape using square units. How many square units are inside of this shape? Feel free to pause this video to give yourself time to count them. Were you able to count all of them? How many square units are in this shape? What is the area of this shape? Yeah, 12 square units. Great job. There are 12 square units in this irregular shape. So far, finding the area has been very easy because we've shown you the inside of the shape, so all you have to do is count how many units are inside. But what if you can't see the units inside the shape? What if there are just numbers that you know and you have to come up with the area another way? Here is the fun part. To find the area of a shape, you have to use multiplication. Yeah, multiplication! So, how do you find the area of a square or a rectangle using multiplication? All you have to do is multiply the length times the width to get the area. Here, we'll show you. Let's say we want to find the area of this rectangle. It is 6 feet long and 1 foot wide. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. The length times the width is the area. It's just simple multiplication. So we would write 6 times 1. 6 times 1 will give us the area of this rectangle. What is 6 times 1? Do you know? Yeah. 6 times 1 is 6. Whenever you multiply a number times 1, it stays the same. So our answer is 6 feet squared. That little 2 next to feet means squared. It tells us that the rectangle has 6 square feet of space inside. The area is 6 feet squared. Why don't we try another one? Let's say we want to find the area of this square. It is 3 centimeters long on each side. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. For a square, the length and the width are the same size, aren't they? Well, the length times the width is the area, so we just have to multiply. We would write 3 times 3. 3 times 3 will give us the area of this square. What is 3 times 3? Do you know? Yeah, 3 times 3 is 9. The area of this square is 9 centimeters squared. That little 2 next to centimeters means squared. It tells us that the square has 9 square centimeters of space inside. That was so cool. What about this rectangle? What is the area of this rectangle? As you can see, it is 4 meters long and 2 meters wide. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. The length times the width is the area. It's just simple multiplication. So we would write 4 times 2. 4 times 2 will give us the area of this rectangle. What is 4 times 2? Do you know? Yeah, 4 times 2 is 8. So the area of this rectangle is 8 meters squared. That little 2 next to meters means squared. It tells us that the rectangle has 8 square meters of space inside. As we are wrapping up, we want to share 2 quick tips about area. As you saw from our examples, when you find the area of a shape, the answer is always squared. If we discovered the area of a shape was measured in feet and the answer was 50, our answer could be written 50 square feet or 50 feet squared. The answer is always squared because area tells us how much space is inside a shape. The little 2 means squared. The second thing we want to mention is that you have to use a different multiplication equation to find the area of circles and triangles. In this video, we just learned the basics of area and how to find the area of rectangles and squares, but this is just the beginning and the start of an exciting math world. There is so much more about area to learn. Great job learning about area. That was cool. We only have 2 lessons left. I'm amazed. This truly has been an epic math adventure. Whoa! Next, we're going to learn all about patterns. 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 They are all around us. You can see patterns in buildings, patterns are used in clothing and design, and patterns are everywhere in math. Just look at the numbers on this ruler, the lines on this ruler, the lines on the paper. You might be wondering, what do patterns do? Well, patterns do the same things over and over again. Patterns repeat. Now this is super cool. Every pattern follows a special rule. The rule is how the pattern works. We'll give you an example. Look at this pattern. It begins with a red rectangle followed by a yellow rectangle. Next is a red rectangle and another yellow rectangle. Next is a red rectangle followed by another yellow rectangle. It's doing the same thing over and over again, so it is definitely a pattern. What special rule does this pattern follow? Well, rectangles alternate between red and yellow. Do you see that? The rule tells us how the pattern works. In this pattern, rectangles alternate between red and yellow. So remember, every pattern follows a special rule. The rule is how the pattern works. If you figure out the rule, you've cracked the pattern's code. Even if there is a part of the pattern missing, you will be able to find it because you cracked the code. Here's the pattern we just showed you. Imagine this spot missing. What belongs in this spot? Well, let's think of this pattern's rule. Rectangles alternate between red and yellow. So what color rectangle goes here? Yeah, a red rectangle. By figuring out the rule, we were able to fill this spot in the pattern. Alright, we have another pattern here. Instead of shapes, we have numbers in this pattern. The first thing we need to do is find out what makes this a pattern. Look at each of the numbers and see if you can see a pattern. What rule does this pattern follow? Do you know? Yeah, You always add 1 to get the next number. Every number goes up by 1 each time. That's the pattern. Great job. Okay, now we are going to play a game called Complete the Pattern. We'll show you a pattern, and then you can try to crack the code and complete it. Here's the first one. You'll notice there are a lot of shapes here, so we should probably just look at this pattern line by line and see what we discover. On this first line, we see a green circle, a blue square, and a green circle. It's almost like a blue square sandwich. The second line is similar to the first, except there are 2 squares in between the green circles instead of just 1. This third line is just like the second line, except there are 3 blue squares in between the green circles instead of 2. Notice a pattern? So let's complete this pattern. How many blue squares are in this fourth line? Yeah, 4. The fourth line has 4 blue squares in between the green circles. How can we know that? Well, the blue squares increase by 1 each line. The blue squares in between the green circles keep growing by 1 every line. That's how this pattern works. Great job. All right, Andy, really? He does this every afternoon. It's a pattern for him. Every afternoon he dances near the woods. We are playing Complete the Pattern, Andy. We don't have time for these super cool dance moves. They are pretty cool. Okay, they are. Oh, goodness. Kevin, I know you dance every afternoon as well. That's a pattern for you, too. But, Kevin, we really do have to get back to our game, okay? Come on. All right, if there are no more interruptions, all right, let's look at this next pattern. Oh, goodness, look at this series of creatures, these animals. The first is an interesting-looking hamster, followed by 2 birds. Then there's a hamster, and then there's a mystery spot that we have to complete, and a bird, and then the hamster, and then 2 birds. That's pretty cool. Let's complete this pattern. Just by looking at this pattern, what do you think goes in this spot? Yeah, a bird. A bird goes here. Now, how do we know that a bird goes here? Well, to crack the code and figure out the pattern, we have to look at the clues. We see a hamster first, followed by 2 birds. Then another hamster and 2 birds, and it goes on and on. The rule for this pattern, then, is that a hamster is followed by 2 birds, and then the pattern repeats. Patterns repeat. Andy, please. Okay, the kids are learning, please. All right, patterns repeat. I was kind of waiting for Kevin. Okay, I guess he isn't going to interrupt him. Kind of impressed. Oh, never mind. Never mind. Apparently I spoke too soon. All right, Kevin, we really do have a final pattern to look at, okay? I think we're ready. Here is the final pattern for us to complete. Is this a pattern with shapes or numbers? Yeah, numbers. We need to figure out what the final number is in this pattern. Look at the different numbers and see what pattern you notice. Once you figure out what rule these numbers are following, you'll be able to figure out this last number. What is this missing number in the pattern? Yep, 4. Great job. How do we know that this missing number is the number 4? Well, what rule did you notice the pattern was following? Yes, subtract 1 to get the next number. So the first number is 9, and the next number is 1 less than 9, 8. Then you subtract 1 to get 7. You subtract 1 to get 6. You subtract 1 to get 5. And finally, you subtract 1 from 5 to get our answer, 4. Okay, it's official. You are awesome at patterns. It's true. It's true. Patterns are so much fun. When you see a pattern, you can try to figure out what rule it is following. Patterns are all around us, just waiting to be discovered. Nice job learning about patterns. And congratulations, you have made it to the last lesson, the last math topic. Are you ready? Because you are about to learn about something that's pretty cool called probability. 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 Probability is the chance of something happening. That's pretty simple. Probability is the chance of something happening. I'll show you how it works using coins. Yeah, coins are fun. Especially to spin, okay? Look at this spinning penny, and it might look like the penny's alone. Don't worry, the penny has coin friends. Let's say you have these 5 coins, 3 pennies, 1 dime, and 1 nickel. You decide to randomly pick a coin to spin on a table. This is going to be a totally random pick. You aren't going to peek. If you randomly pick one of these coins, how likely are you to pick a penny? That's a good question. Well, more than half of these coins are pennies, so the answer is likely. You will likely pick a penny. Likely means there's a big chance. Okay, how likely are you to pick a dime? Well, that's different. There's only 1 dime. Only 1 out of the 5 coins is a dime. How likely are you to pick a dime? The answer is unlikely. Unlikely meaning there's a chance, but you probably won't. You are unlikely to pick a dime. Well, let's not leave out the nickel. How likely are you to pick a nickel? Well, let's think about it. There's just 1 nickel out of 5 coins, just like we had with the dime, which means there's a chance you might pick the nickel, but you are unlikely to pick it. The answer is unlikely. You are unlikely to pick a nickel. All right, here's another situation. Say you are at a baseball game and you found some pennies. 4 pennies, in fact. Just to be silly, you decide to randomly pick a coin in your pocket to see which kind you pick, even though all 4 coins are pennies. How likely are you to pick a penny? Well, you have to pick a penny, right? Because that's the only option. You are certain to pick a penny. The answer is certain. In probability, we use the word certain to mean there's no chance of anything else happening. You are certain to pick a penny, 100%. Now let's look at a completely different scenario. Say I want a green balloon because green is my favorite color in the whole world, which it actually is. I don't know why, it just is. Green has always been my favorite color. All right, so I go to a store to try to buy a green balloon, but I don't know they only have red and blue balloons. All the other balloons are sold out. How likely am I to buy a green balloon at this store? Well, there aren't any green balloons, so there is no chance. It is impossible to buy a green balloon from this store on that day. Impossible is the word used in probability when there is no chance of that outcome happening. I can't buy a green balloon from this store right now. It's impossible. I'm just kidding. It might be impossible to buy a green balloon from this store today, but there's no way I'm giving up. I can go somewhere else and look for a green balloon, or come back here another day once they get more green balloons in. All right, so probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain, that means you have a 100% chance it will happen for sure. There's likely, that means you have a big chance. There's a big chance it will happen. Then there's unlikely. That means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day. That does not mean it will always be impossible. In fact, the probability or chance of something happening can change. Maybe you find another coin at the baseball game, a nickel this time. Or maybe a delivery truck arrives and suddenly I do have a chance of getting a green balloon at that store. Okay, now it's time for a probability quiz. I need your help. Pretend you are at a movie theater. You've been picking up coins you found along the way, 7 in all. 4 nickels, 2 dimes, and 1 penny. While you wait for the movie to start, you pick coins randomly without looking. How likely are you to pick a nickel? How likely are you to pick a nickel? Likely. Correct. You are likely to pick a nickel. More than half of the coins are nickels. You have a big chance of picking a nickel. That means it is likely. You are doing great. All right, how likely are you to pick a penny? Penny. How likely are you to pick a penny? Unlikely. You are unlikely to pick a penny. There's a chance you could pick a penny, but it's just a little chance. Unlikely. What's next? Oh, how likely are you to pick a dime? A dime. How likely are you to pick a dime? Unlikely. Yep, you are unlikely to pick a dime. With only 2 of the 7 coins being dimes, there's only a small chance you'll pick a dime. Unlikely. Okay, here's the final question. How likely are you to pick a quarter? A quarter? How likely are you to pick a quarter? It's impossible, yes. If you only have these 7 coins, it's impossible to pick a quarter because none of them are quarters. It's impossible. But remember, if you find a quarter later on, add that to your collection and play the same game, the probability would change. It wouldn't be impossible anymore, but it would be unlikely. So, probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain. That means you have a 100% chance. It will happen for sure. There's likely. That means you have a big chance. There's a big chance it will happen. Then there's unlikely. That means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day. That does not mean it will always be impossible. In fact, the probability or chance of something happening can sometimes change. You did such a wonderful job learning about probability, the chance of something happening. I think Mr. Whiskers is likely to agree. No, he's certain to agree. 100%. 100%. Mr. Whiskers. Was I crying? Well, anyway, amazing job. You did it. Congratulations. This has been a lot of fun. I hope you'll revisit this video and stop by whenever you want more math. I'll be here with Mr. Whiskers and the beaver and this dog and Clancy and so many others. But just know you are a math champ and I think you are super cool. Hey, if you enjoyed this and haven't yet, be sure to subscribe to my channel. I have so many learning videos to explore. I want to give a special thank you to my patrons. Your support means the world to me. And thank you for watching. You are so awesome, and I can't wait to see you next video.